begin.
What you think that you think that you think that we think is cool? You think that you think that you think that what
Okay, is it working now? Can you hear me now? Woo! All right. We got it, folks. We got it. You know what happened? Streamlabs suddenly decided that all of my audio devices would be unmapped. It was just going to be like, nope, you don't get to use any of your audio devices. So it was definitely a Streamlabs problem. We are live and indeed live and alive. Yes. Yep. We are now alive. So thanks for your patience there, everybody. Sorry about that. Um, I know. Well, I had to go to global settings and it literally just unmapped all of my audio devices for no particular reason. It just showed them all as like the just default, random string of numbers rather than the actual audio device. So that was fun. Streamlabs, what are you doing to me? I still miss Twitch Studio, honestly. Of course it did. Yeah, it's got to keep me on my toes, right? Got to wake you up on a Sunday. Can't be complacent. Okay. So let me know if it cuts out again, but I think we're cooking. I think we're cooking now. All right, I'm going back through chat here. Prieto asked, "Is this going to be recorded? I'm at work and can't watch right now." Yes, all my streams are recorded, and I'll be moving a bunch of them to YouTube soon. Some of them are already on YouTube; they're just private. I will publish those soon. When I start, taking breaks for Thanksgiving and stuff, I'm gonna publish a bunch of videos so y'all have something to occupy your time. All right. Also, hello, everybody. I know you couldn't hear me the first time I said that. So, hello. I hope everybody's having a great weekend so far. It is weirdly warm here today, but still a good day to stream and a good day to learn some Python. So, we are continuing with our Python learning journey today. We're going to be talking about lists. Now, we try to cover, at least one lesson per stream, maybe two. This particular stream, I think, will probably be only hitting one lesson today, just because I have looked through the content here for this lesson, and it gets a little spicy. This is a little bit of a harder lesson, just with a lot of new concepts and some theory to think about. So I imagine we're probably going to be just focusing on lists today, but we'll see how far we get. Our goal is to at least get through lists. All right. It maps out random your mic to 0. Yeah. I'm just gonna have to learn to read lips. Uh, yeah, I don't know, Mattel. I don't know what happened there. Yeah, it did look like a registry key. I don't know, nothing else was using my audio. When I opened up Streamlabs, the only other thing I had open was Chrome here. So I don't know, and Chrome, wasn't booking my microphone. So I don't know what's going on there, but Streamlabs is going to Streamlabs, I guess. Yep. I peaked. Well, at least I'm not peeking my mic, but I did peek at the content here. Yeah. Was borked indeed. Yes, today is a good day to learn Python. It is, absolutely. Before we get started, a couple things. So first off, if you want or need closed captioning, if you are, in need of live generated captions, you can hover your mouse over the right side of the screen. You should see a little pop-up up here. It'll have a closed caption icon. If you click on that icon, you will get custom generated captions of the words that I am saying. So feel free to do that if you need them. Thank you for the follow. I am Machine. I never sleep. Thank you so much for the follow. Happy to have you here. I hope you do sleep sometimes. Sleep is very important for you to be healthy and to have your best learning experience. Buenas tardes. Hello. Hola. Welcome. Good afternoon to you as well. Yeah. Let's see. Other thing. Also, another thing that's very important. Please do follow me on Blue Sky. So I'm trying to migrate my primary sort of social media presence from Twitter to Blue Sky. So I would really appreciate it if you could give me a follow there. That's where I'm going to be announcing all my streams and topics, just like I do right now on Twitter. That's where I'm going to kind of move my primary presence to. I'm still going to keep posting on Twitter for the time being, but my goal, once I kind of move at least a major portion of my followers, if I can, over to Blue Sky, then I'm just going to, you will no longer have access to my Twitter account. I don't know exactly what I'm going to do with it, but it's not going to be a public account anymore. And then, the conversation will continue on Blue Sky. So if you want my Blue Sky information, do ! Blue Sky in chat. That'll give you my name. But luckily, it's pretty easy. You can just search for Mayan Wolf on Blue Sky, and you can follow me there. Yep. Beaver Logic says, I'll do it for y'all too, real quick before we get back to the chat. Test the command. There you go. Yep, so I'm just Mayan Wolf, just like I am everywhere. So you can find me on Blue Sky. Beaver Logic says, I'm always somehow sad how these things are taught from the practical, this is how you do this thing, without starting from the why do we even do these things. Yeah, and that's a reason why I really like this course. Because it often does start from the why do we care, right? Why do we care about this thing that we're learning? And that really resonates with me. That was one of the things I really struggled with in college, is that, in college, a lot of the things you learn are just like theory, or, you're just learning a concept without, okay, why do we care about this? Why should I invest my time and energy into learning this thing without ever knowing when or how it should be applied in the real world? And theory is fun, and theory is very important because it leads to practical applications of things. But learning theory just for the sake of theory, it doesn't do anything for me mentally, right? It's like, why am I wasting energy on this? So for me, that was a real struggle in college. And so that's one of the reasons why I really like 100 Devs. And I really like this course because they have a similar philosophy of teaching from the application first. And then they teach you, okay, you want to be here, you want to do this thing. So what are the things you need to know to get there? And I really appreciate that. Now, some people love learning theory and they enjoy doing proofs and stuff like that. And that's fantastic. I love that. I wish I had that level of enjoyment, but I really don't. And so that's why, courses like this are great, because they start from kind of the application of, okay, we're trying to do this thing. And then, okay, what concepts do we need to know in order to get to our end goal? So I totally agree with you, Beaver. I think, practical application type courses like this are great. There's many ways to do things. Yeah, that's one of the things, that's one of the biggest stumbling blocks for some people when they're learning to code, is that there are a lot of different ways to do things. Oftentimes there's no right way to do anything when it comes to coding. You just have to go with the way that you're comfortable with, that that fits the process of your organization, and that is gonna get you the right result. Katavari says, "Don't read captions while driving." Yes, be safe. If you're in the car, you shouldn't be looking at the screen. You can, if you have the Twitch mobile app, you can enable an audio only mode. Where it's voice only. So if you didn't know that, if you're on mobile right now, you can enable audio only, which I would highly encourage you to do if you are driving or operating heavy machinery. Hey, Ahmed, good to see you. And Pedro and Katavari, Celeste, Beaver. I didn't say hello to everybody. I kind of got thrown off of my game here at the start of the chat with my mic issues. Preto, Iced Fire, Dooku, good to see everybody. Wadekin, KP. Hey, Phenomenal Spark, welcome to the stream. Good to have you here. Hope you're having a good day. And Melkor1618, thank you so much for the follow. Good to have you here. Okay, I think that's everything with my preamble here. Does anybody have any questions before we get started? I'm going to do a quick hydrate here. Thank you, Arath, for the follow. Good to have you here as well. Mattel says, learning is understanding, not just regurgitating and repetition. Yeah, and regurgitating especially. Phenomenal. Thank you so much for the follow. Good to have you here. I'm Rabinia. Hello. Hi, Melkor. Yeah, I will say that repetition is part of learning. It's not the only part, but repetition is actually a very important part of learning that a lot of people overlook. Um, because repetition is literally what builds the physical pathways in your brain. So reading something once and then maybe doing some practice problems and then never touching it again, that's not learning. That's not going to actually make you remember it. So, you know, I think application and repetition are probably the most important parts of learning. Um, so yeah, I think it's important to, kind of make a distinction there that repetition is indeed an important part of learning, but it should be paired with application of your knowledge, not just memorization. Mattel says, "How big is that cup? It looks giant." Yeah, it's huge. I used to work for a company that printed home goods and apparel and mugs. So, you those kind of things like, you put your picture of, you take a picture of your mom and you want to get her a mug for Mother's Day. And so, you print it on a mug and you get that, sent to you. I used to work for a company that did that. So they would print on home goods, print custom home goods and mail them to people. And so the nice thing about working there, as I worked in the production facility as a manager, I was like the data manager for the production floor. And so we got to look through all the scrap or all the badly printed items, and we could basically just take stuff home. So a lot of my home decorations, like pillows, wall canvases, even some of like my workout pants and stuff like that, they are uh, from the discard pile at my former job. I mean, not terrible. Usually just slight misprints or customer returns. So yeah, a lot of that is free junk from work from my old job. It was a pretty soul crushing job in general, but I did get a lot of free stuff, so that was nice. Yep. Mattel says I need to find a giant metal or ceramic cup for my tea. Yeah, I think this thing is like 21 ounces. It's huge. It's great. I love it. I have two of them. King Missile has a song called Take Stuff from Work. Yeah, I mean, hey, I'm not advocating for anything in particular, but if you have the permission to, get yourself an extra notepad, or, if you have, because, I don't know. I feel like so much of production is so wasteful that if you can give any of that stuff a new life, then why not do it? It's all part of the compensation package. Yeah, I will say when I did used to work in a cubicle, I went through a bunch of pens and notepads, and then when we all went to work from home, like we all had to clean out our cubicles and go home, they had a bunch of office stuff like those big heavy duty whiteboards and markers and stuff like lined up in the hallway, just because they were gonna just get thrown out, and they're like, you just take stuff. And so I'm like, heck yes. So I have two big, conference room whiteboards at my work desk, and I got a nice steel case chair. So yeah, I mean, I can't keep the chair unfortunately, but definitely got to take some stuff from the office when we all went home. Oh boy. Okay, let's go ahead and get started. Let me know. And as always, if you're new here, welcome. This is an educational stream, so we're going to be learning together. I'm going to be talking through the written material, but occasionally I'm going to ask you all questions in chat, because that's how we learn, is we engage with the material, we think critically about the material, we question ourselves and quiz ourselves on whether we understand what we just learned. And also too, there's no such thing as a silly question. So if we're going through something and you don't understand it, or you're not sure what I just said, or you'd like me to go over something in a different way, please ask. And you're welcome to ask questions. There's no such thing as a silly question, because if you have a question, that probably means that somebody else in chat has the same question. You're just the one that was brave enough to ask that question. Okay? All right, so let's go ahead and get started. We are using Python for Everyone, which is a free course that was put together by a professor at the University of Michigan, Dr. Chuck. He has done several other courses in a similar manner, including one on Postgres, one on PHP, one on C++, and a few other courses as well. So highly recommend. This course has been fantastic so far. So if you'd like to learn another language, you might see if he's done a course on it. And the website is just up here. If you do !project in chat, you'll get a link to the screen that we're on. Well, you'll get a link to the full list of lessons. And if you are following along today, I would highly suggest that you log in. The course tracks your progress. It tracks what you've completed. It tracks your quiz scores. So if you're following along, again, highly suggest that you log in and get credit for the work that you're doing while you follow along with me today. All right. Utkar, welcome. Hello. List questions. Yeah, we're going to be going over lists today. Yep. All right, we're going to go ahead and get started, and we are following the written material, like I mentioned. However, if you prefer to learn a different way, Dr. Chuck also recorded videos for the same material that we're going to cover. So if you prefer to watch a YouTube video and follow along, with someone other than me and talking about the material, you're welcome to watch these videos as well. And when we are done, as we were talking about the best ways of learning earlier, when we're done, we're going to do a couple of exercises. We're going to apply what we've learned, and we're going to take a quiz. We're going to do all these things together. We're going to agree on the answers for the quiz. We're going to work through our mistakes on the exercises, and that's going to help cement this information in our heads. All right? Cool. Let's get started. We're going to talk about lists. I'll move over my code window. We don't need that just yet. And let me know if you need me to zoom in or anything, but I think this size has been pretty good for folks in the last few streams. So what is a list? Well, like a string, a list is a sequence of values. So in a string, those values are characters, and in a list, they can be any type. The values in the list are called elements or sometimes items. Now, just kind of looking at this, what does this resemble? If you're familiar with another coding language like JavaScript, what does this look like? Yeah, Utkar and Palooza. Yep, it looks like an array. Hey, Reswan, welcome to the stream. That's a cute little parrot emote. I like that. Yeah, it looks like an array, right? Yeah, so a list is essentially what Python calls arrays. Now, you might occasionally catch me slipping up and also calling it an array, and I apologize. It's just me trying to kind of translate between those two. So there are several ways to create a new list. The simplest is to enclose the elements in square brackets. So just like an array, we would take a list of elements. Notice how they're delimited with a comma. And we put them in brackets to make them into a list. Beaver says, question, if a list is a sequence of elements and strings are sequences of characters, why aren't strings then lists? Well, I think we're going to get into the differences between those two in just a minute. But yes, you can do some similar things with strings that you can do with arrays, but we are going to talk about some of the differences between strings and arrays here pretty soon, which might help answer that question. But yeah, you can do some things with strings that you can do with arrays, but it's more like a Venn diagram, right? You have two circles, one of them is arrays, one of them is strings, and there is some overlap there, but there's also some things that you can do in one, but not the other. Marfin says, arrays in JavaScript are objects. Exactly. Yes, you're not wrong. Trillium, welcome to the stream. Hello. Like an array. Exactly. Yeah, you're exactly right. Yep. Hey, Cellophane, welcome to the stream. Res1 Coder, thank you for the follow. Cellophane says, what's a multi-dimensional string? I'm not sure if that's a thing or not. Somebody is welcome to answer that question in chat if you know the answer. That just makes me think of, something science fiction-y. Oh, multi-line string. Okay, so multi-dimensional string being a multi-line string. Got it. Okay, thank you, Udkar. String theory, yeah. All right, here we go. So this first example is a list of 4 integers. The second is a list of 3 strings, but the elements don't have to be the same type. So as we can see here, first is a string, second is a float, third is an integer, and then we also have a nested array here, right? So we have, 4 different data types in the same list. A list within another list is nested. A list that contains no elements is called an empty list and is denoted with brackets like so. And you can, just like with a string or something similar, you can assign a list to variables. So here we have a list of cheeses, so we assign it to a variable called cheeses. We can, here's a numbered list, we can assign it to a variable called numbers, etc., etc. Now, here's where we get into some of the differences between strings and lists. Lists are what we call mutable. So just by looking at this word, even if you don't know what this word means, by looking at this word, can we get a sense of what the word mutable might mean? Where else have we seen this prefix mute, M-U-T? What's another word that sounds similar? Mutate, yeah. And what does mutate mean? It means that it can change. Mutation means change. And it means an object that itself is changing, right? An object has become altered in some way. And so we might find that helpful in remembering what the word mutable means. Super Beer, that's a great name. Thank you so much for the follow. Good to have you here. Mutants, yeah, mutate, mutants. Hey, Faffin, good to see ya. All right, so the syntax for accessing the elements of a list is the same as for accessing the characters of a string, the bracket operator. The expression inside the brackets specifies the index, and as we know, indices start at 0, right? So if we print cheeses 0, we know that it's going to print the first value in our cheeses list. Ruben Rojas, thank you so much for the follow. Good to have you here. Now, unlike strings, lists are mutable because you can change the order of items in a list or reassign an item in a list. When the bracket operator appears on the left side of an assignment, it identifies the element of the list that will be assigned. Okay, so let's pause there for a second. So here is a difference between strings and arrays. Lists are mutable because you can change their order or reassign them. And we're going to see multiple examples of this. Okay? We're going to see multiple examples of ways that we can mutate an array. Now, in strings are immutable. Strings are immutable. So if you have a string, in order to change it, what do you need to do? If it's immutable, what do you need to do? If I want to, I don't know, change the last letter of a word in a string in Python, what do I need to do? I can do it, but how do I do that? We talked about this last week, so here's a little active recall for you folks. Anybody remember, if we want to modify a string in Python, what do we need to do? Yeah, we need to create a new string and make that change. So we take the original and we, do whatever we want to it. But we need to then assign it, essentially to a new variable, and we're creating a new string when we do that. So we can't change the original, but we can put our changes into a new string, into a new value, but we can't change the original directly. Ruben says it's like replace with the index number. Well, yeah, so we can use indexing when working with strings. So we can say, if we want the first letter of a string, we can say, index 0 of that string and get that string. But if we want to modify it, then we have to assign it to a new string, essentially. The original stays exactly as it was, and then the modified version becomes a new string. Now, that's not true with arrays, though. And we're going to see multiple examples, like I mentioned, we're going to see multiple examples of that here in just a bit. So here's an example. Yeah, we can't modify a single character in a string because it's immutable, but we can create a new string that looks exactly like the old one, but the first letter is modified. Yeah. So here's an example of how arrays are different. Here's an example of how arrays are different. Here we have an array called numbers, and it contains the values 17 and 123. Now, what are we doing here? We're taking numbers, the original list, and we are changing the second value to 5. We're saying, hey, go into the list numbers, take the second value at index 1, and set it equal to 5. Now, if we print that list, I'm going to get that wrong every time. If we print that list, we can see it has been changed to contain 17 and 5. The original list has been modified. We don't have to create a new list. We can modify the original. All right. So you can think of a list as a relationship between indices and elements. So the locations and the things at that location, right? So the index here is 1 and the value is 5. That's the index and the element. This relationship is called a mapping. Each index maps to one of the elements. So list indices work the same way as string indices. We kind of talked about that. Any integer can be used as an index. If you try to read or write an element that does not exist, you get an index error. And if an index has a negative value, I think Utkar mentioned that, if an index has a negative value, it counts backwards from the end of the list. So let's say that I had a list and I didn't know how long it was. I just know, let's say I know that there's a list that contains all the words in the Declaration of Independence. So the United States Declaration of Independence. I don't know how many words are in the Declaration of Independence, but let's say I wanted to retrieve the last word. How could I do that? Let's say the Declaration of Independence, all the words are stored in a list that's called, words. They're stored in a list that's called words. If I wanted to get the last word from that list, what would I do? How would I locate that last word? It's stored in a list called words. How would I return the last word in that list? Told you all I was going to ask you questions. Yeah, if we don't know the length, exactly. Trillium, Mattel, Utkar, yep. If we don't know the last index value, we could do -1. So we find the value at -1 and return that. Yeah, it's not going to be -0 in this case. It would be -1. Yep. Yep, exactly. So that's what we're referencing there. If an index has a negative value, it counts backwards from the end of the list. So you could do -1, -2, -3, etc. Yes. Now, the in operator also works on lists. So it can check whether a value is in that list. So for example, here, we're checking to see, is Edam in our list of cheeses? And in this case, that returns true. Now, is brie in our list of cheeses? It returns false. And that's a crime because brie is amazing. I don't know if anybody else out there likes brie, but it's like my favorite kind of cheese. And I don't know why they wouldn't put it in their special little list, but it needs to be. So I know, right? William says brie not being in that list is crazy. Exactly. Matt's Coding, thank you so much for the follow. Good to have you here. Right? Yeah, brie deserves to be there. Okay, so now we know how to access the items in a list. How do we traverse a list? And traverse just means, how do we move through a list? We talked about a little bit last week how we can, let's say, loop through a string, right? How we can loop through a string, how we can, loop through any set of data, right? And the same holds true for lists. They seem to be Dutch cheeses here. Yeah, might be a little bit of a nationality bias or something there. I don't know. So the most common way to traverse the elements of a list is with a for loop. And it's the same as with strings. So again, another similarity there between lists and strings. So for are for cheese in cheeses, print cheese. Essentially what this is going to do is it's going to loop through all the values in our cheese list and print each one. Now, so this is our array name, right? Cheeses. What do we call this? We talked about this previously. Here's another bit of active recall for you. If we're doing a for loop, this is the thing we're looping through, but what do we call this? What do we call this? Does anybody remember? It is a kind of a variable. Yeah, Palooza. Cheesy element. That's a good guess. I like that. Wish it were true. What do we call this? Cheesy element is the answer. Oh, it's the answer in my heart. Yes, exactly. Dooku, correct. It is the iterator variable. So you're not wrong when you said it was a variable. But what type of variable is an iterator? So an iteration, again, just means that we are stepping through something, right? So this variable is essentially controlling how many items we step through. So for every item in our list, do something. Now this could be something different, but we're setting our iterator to be, all right, to control how many loops we end up doing. And this is just saying, all right, do as many loops as there are items in your list. So it's an iterator because it's controlling how many loops we end up doing. So that's just a good word to know, is iterator. If somebody says that, especially like something in an interview, you'll want to know what that word means. All right, so we can just set it to each item if we just want to loop through every item in the list. And this works well if you only need to read the elements in the list. But if you want to write or update the elements, you need the indices. And a common way to do that is to combine the functions range and len. And what does len mean? What does len stand for? Yeah, yep, William, Lenny. It stands for the length. Exactly, it stands for the length. So exactly, how many elements are in our array. And remember that length is different than index. Length is different than index because indices start at 0. So just be careful when you're working with length versus index. So what are we doing here? For I in range, len, numbers, we're taking the number at that particular index and we're multiplying it by 2. So what we're doing here is we're taking the base array of numbers and it's traversing that list and updating each element. So what's happening here? Well, length is returning the number of elements in the list, and range returns a list of indices from 0 to n-1, where n is the length of the list. So each time through the loop, I gets the index of the next element. The assignment statement in the body uses I to read the old value of the element and assign the new value. So essentially what that's saying here is that, all right, so find the index at each value we're looping through. And then for the value at that index, take the existing value and multiply it by 2 and then reassign it. So when we're done, we're going to have the original array, but all the values in it are going to be multiplied by 2. Yeah, and range, as Trillium defined there, range is just a function. It returns a range, right? It returns a list of numbers based on the passed in parameters. Yep. So in this case, range is going to return a list of indices from 0 to n-1, where n is the length of the list. Yeah, and a lot of these, it is important to remember too that a lot of these functions and methods could have multiple arguments. However, in most cases, the default is going to be, no additional arguments. However, as we saw last week when we were working with files, by default, when you're opening a file, right, you just kind of pass in the file name. But if you wanted to write to a file rather than read from it, you would have to pass in an additional argument to write. So a lot of these things can have additional arguments, but for their default kind of operation, we don't necessarily need them. So they're not something that's required, but some of these can have additional configuration, and that's something that you can look up in the documentation. So just like anything, you should go and read the docs if you need some additional context or additional configuration on a function or a method, and see if there might be some additional arguments that you can manage. Okay, a for loop over an empty list never executes the body. Hey, Akechi, good to see you. So if our list is empty and we try to print something, it's never going to happen because the for loop can't execute. There's nothing to execute on. Although a list can contain another list, the nested list still counts as a single element. So looking at this list here, its length is 4. So we can see here's 1 item, 2, 3, and 4. Now, how can we tell that? Well, I'm looking at the delimiters, at the commas here. So what are the commas at the top level of this list? Well, the first one is here. The second one is here. The third one is here, all the way after this list. This is our third comma. And then the last element is here. So you have to be very careful when you're looking at a nested list like this, that you don't get yourself twisted in terms of how many elements are actually in the list at the top level. It doesn't care how many elements are here, how many elements are in each top level element. It only cares, all right, how many items do I have between the delimiters? Okay. So what else can we do? Well, just like with strings, we can do concatenation. So we can use the plus operator to concatenate lists. So we have 2 separate lists here. And if we say list A plus list B, suddenly we have one unified list with all the elements from A and all the elements from B. And again, just like with strings, we can use the star or multiplication operator to repeat a list a given number of times. So, a list of 0 times 4 simply multiplies the list times 4 and returns essentially those elements times 4. So here's maybe a better example. With this list here, it has elements 1, 2, and 3. If we multiply it by 3, what we get back is those elements repeated 3 times. So the first example repeats 4 times, the second example repeats 3 times. Yeah, Cellophane says, interesting. You can multiply lists like strings. Yeah, you absolutely can. Now, I was trying to think, just out of curiosity, what might be some practical applications for doing this? Cellophane says, I didn't know that. That's awesome. Yeah. I was just trying to think, kind of off the top of my head here. Can anybody think of some practical applications why we might want to multiply elements this way and, cause them to repeat? I'm genuinely asking. I'm trying to think right now, what would be a practical application for this? Could anybody think of some? Here's a question, we're learning this, right? But what might we be able to use it for? What might be a use case? Because I was thinking, for strings, we can cause a string to repeat X number of times, and that could be useful. For example, if you want, a string to repeat on a certain cadence, to indicate that something is loading, or indicate the status of a particular tool, right? Just keep repeating that string value X number of times. Cellophane says making a column and row repeat. Yeah, I mean, if you're doing like a matrix or something, I don't know. I'm just trying to think of a practical application where you would, for a list, right? Just for a plain old list, what could be something we could use this for? Yeah, it's an interesting question, isn't it? Trillium says, yeah, actually, hey, that's not bad. They say maybe initializing a list with many zeros in a Minesweeper game to show that the user has not revealed that section. I like that. That's great. Yeah, that could be something we could do. I've actually built Minesweeper here on stream. And yeah, we essentially did, I think when we built Minesweeper, we were doing it in JavaScript. So we just kind of did a loop and, generated the default layout, just by looping through. But, kind of creating a matrix and looping through that. But yeah, that's an interesting application, certainly. Minesweeper prototyping. Yeah. Yeah. Or yeah, generating a heartbeat. That's kind of what I was saying with the string thing earlier. It could be something for generating a heartbeat. Yeah. So, but so far, I think the best application is Minesweeper. Yeah. The only reason this was invented was for Minesweeper. Got it. Cool. Kanchi says ray tracing, maybe. Ooh, fancy. Yeah, that's a great suggestion, actually. Welcome to the stream, by the way. Hello. Yeah. Yeah, that's a great suggestion too. If you're getting into things like environment generation or whatever. Mm-hmm. Yeah. Okay, slices. So we've talked about slices before, right? We talked about slices in relationship to strings. And what does slicing do? When I say slice, what does that mean? Because we learned about it before in relationships to strings, and it really works the same way with lists as well. What does slicing do? Yeah, Trillium, it returns a subsection of a list. Exactly. It's literally just like taking a slice of cake. You're not gonna just take the whole cake. You're gonna cut off a slice and take a portion of that cake. Now, if I'm cutting a cake, I can control how big my slice is, right? Am I gonna take a quarter of a cake? Am I that ambitious? Or am I maybe going to take only an eighth or 16th of that cake? Or a block of cheese? Yeah, actually, I prefer cheese, honestly. If I have a nice fresh wheel of brie, if I have a nice fresh wheel of brie cheese, um, I'm probably gonna, I usually cut it into fourths, right? So I'm controlling the size of that slice, and I can choose which quarter of that wheel of brie I decide to take. Am I going to take the top right quarter, lower right corner? What am I going to take? So I'm controlling where that slice is and how big it is. And that's exactly what we can do with a string or a list. So our slice allows us to control that. Cake control is a Python specific power. Yeah. All right, so we can do that. We can do slices with arrays just like we do with strings. So here we have a list, A, B, C, D, E, F, and if we grab slice 1:3, that's going to return values B and C. Now, it starts at index 1, right? So we start with value B, the second value. Value A is at index 0, value B is at index 1, so we grab B. Now, it's asking for slice 1:3. So why didn't it return B, C, and D? Because D is at index 3, right? D is at index 3, so why didn't it return D in the output? I'll try, Palooza. I'll try. I can't promise anything. They've banned a specific word that starts with A that I've been saying a lot instead of the word list. So I will try. I think I normally set these at like 10 minutes. So we're going to go up until like, I'll say, we'll go to the top of the hour, see if I can avoid saying that word. So why didn't this slice return D? What happens when you say it? Do they get a refund? No, I just admit my mistake. There's really no punishment. William said it's one before the right side of the slice. Yes. And that is because why? Anthropomorphization. Did you just want to say that word? ATV. Yeah, Trillium says the second number is the stop. Yes, that's correct. So, one important thing to remember about slices is that the first number is the index where we start. And I'm going to zoom in one more here. There we go. The first number is the number where we start, but the second number is the index after where we stop. Okay? So just remember that. And that there was a bit of, a learning curve when we first covered this last time. And so it's really important to remember, that's why I'm harping on this again, is that the first index is where we start. The second index is the index after where we stop. So it's not inclusive if you want to think about it that way. The one is inclusive, the first index is inclusive, the second index is not. Okay? Like a snake. Yeah. Start, stop, step. Yep. Now, just like with strings, we can do the same thing with lists. We can just omit the first index, and that's just going to go to the very start of the list. And, include the last index to tell it where to stop. Or we can include the start index and no stop index. Or if we don't include any indices at all, it's just going to return the whole list. Hey, Kanchi, thank you so much for the follow. Good to have you here. Now, remember, here's another difference between strings and lists. Lists are mutable. So if we are taking a slice, of our list, it's often useful to make a copy before performing operations that fold, spindle, or mutilate lists. And this is a fantastic joke, which I will come back to in a minute. But first, let's finish this thought. A slice operator on the left side of an assignment can update multiple elements. All right, so we start off with the same list as before. And if we say, all right, I want to take a slice and I want to replace the values in that slice with new values, you can do that. So what is it doing here? It's saying, all right, start at B and go to C, stopping before the third index, replacing those values with X and Y. Now, when we print T again, we get a new list. Well, we get the same list, actually, sorry. We get the same list, but with the values B and C replaced with X and Y. Now, again, this is not something that you can do with a string. Strings are immutable. Lists are mutable. This is the same list, just with those two values replaced. So, can you imagine how this might be a problem in real life, right? Or how this might cause you issues potentially in real life? That's why it says specifically, it's useful to make a copy before performing operations that are destructive towards your list. Okay? Because let's say I have a list that is being populated by a weather sensor, right? It's recording the temperature at 5-minute intervals, and it's writing those values to a list. So we're writing, and I'm like, oh, hey, I would love to see, what the temperature ranges are between, 9 and 9:15 a.m. this morning. And so without thinking, I just go in and I say, all right, I'm just going to grab this slice. I'm just going to grab this slice and just see what that looks like. If you're not careful, you could end up only with that slice remaining and accidentally deleting all of the other weather data that you've collected. Okay? So that's, something that could happen. What you should do instead is grab that slice and so create a copy of your original and grab that slice and put it into a new list. Mattel says, do you get an error if you assign more elements than the slice parameters define? Let's try it. I mean, whenever we have questions like this, the easiest answer is to just try it, right? So let's do that. So we're going to start the Python interpreter here, and we're in the interpreter. So I'm going to kind of copy this here, but I'm going to change the I'm going to add an additional element here. So we're defining T as that, and then we're going to say, all right, T, take this 2-element slice, but I'm going to add one more element to it. So I'm in insert mode. That's all right. Y and Z. So we're going to add one more element here. We're going to add Z. And then we're going to print T and see what happens. So it didn't squawk at me. I imagine this is going to be fine. I don't think it's going to care. I think it's going to expand the list, but we'll see. Yeah. So as Trillium said, I think it adds in the additional values, and it absolutely did. So essentially what we're doing there is we are taking the slice and we are replacing it with a new bigger slice, and the array, dang it, I did it. I was so close. The list itself expands to accommodate that additional slice. Exploit city, exactly. So you have to be very careful when you're building stuff to think about how this could potentially be exploited, right? Hopefully your password wasn't the last element in the list, right? Oh, yeah. Okay, now real quick, we have about like 5 minutes before we're going to take a break. I just want to pause briefly for this wonderful joke that, like, when I read this earlier, I was like, this is amazing. So it's often useful to make a copy before performing operations that fold, spindle, or mutilate lists. This is absolutely an old school computing joke. Does anybody recognize it? I'm just curious. Fold, spindle, or mutilate. Anybody recognize that? I'm just curious. If nobody does, that's fine. I'll fill you in. But got any old school coders out there? Yes, you're exactly right, TV Josh. Yes, they say punch cards. Exactly. Yes. So fold, spindle, or mutilate was a message that was do not fold, spindle, or mutilate was something that was printed on the top of old punch cards because if you folded, spindled, or mutilated them, they would not read correctly because old punch cards used to literally be cards with holes punched in them, right? And so, for example, if you put a staple through them or put them on a spindle, like a spindle was just a big paper spike that people would keep on their desks. Like you see them in diners, they'll put the receipts on just a big stack of receipts on a metal spike. That's a spindle. And so if you took a punch card and you poked extra holes in it, then it's not going to work properly anymore because there's going to be too many holes and the computer's not going to be able to read it, or it's going to jam the punch card reader. Yeah. So if you're curious and you want to read more about punch cards, there is a Wikipedia page on this, and I will put it in chat for you. So I highly recommend it. I'm fascinated by punch cards. They're really cool. But yeah, punch cards. Check it out. I just love that he put that little joke in there. It's great. I might be the only one that was tickled by it, but I had to call it out because it's fantastic. Okay. Moving on. All right, so we just did that one. We tested that out. Okay, so list methods. Mattel says we had to learn how to read punch cards in my high school programming class. Oh, that's neat. Yeah, I never got that experience. Unfortunately, my high school was very rural. We'll say that. It was out in the middle of nowhere, and they taught us how to type, and that was it. So I wish I would have had programming in high school. I probably would have discovered a love for it a lot sooner in life. But hey, you get what you get, right? I'm sure someone has cellophane. Yeah, I'm sure. So what are some list methods? Well, just like with strings, there are some built-in operations that we can do on lists. So how do we chat? How do we call a method? How do we call a method? If we want to use a method, how do we call it? And by call, I mean, call means invoke, right? Use. How do we use a method in Python? What's the syntax? Mattel says dot operator. Yeah, exactly. So we invoke a method in Python the same way we do in JavaScript. Exactly. We use the name of the variable and then dot and the name of the method, and then we can pass in any arguments. Exactly. Trillium and machine, you're exactly right. So just like we would in JavaScript. So in this case, what we're doing here is an append. So the append method adds a new element to the end of a list. So if we want to say, all right, I've got A, B, C, and I want to add D to the end, and then I print the original list, it now has one additional element. Hey, Melodzi, welcome. Good to have you here. They say how to handle pressure in Scrum sprints as a Java developer. Well, I'm not a Java developer, but I can talk a little bit about handling pressure. We'll do that after the break. We're not going to do that before the break, but we'll do that after the break. We'll talk a little bit about pressure. How do you handle pressure in sprints? Yeah. So extend takes a list as an argument and appends all the elements. So there's a difference here, right? Here we're just appending one element. When we extend, we're actually adding an entire other list. So we're putting a second list on the end of the first list. So there is a difference between these two. This is just, I want to add a single element. I want to essentially merge two lists with the second list at the end of the first. And just important to note here, this example leaves our second list unmodified. So what we're doing here is we're saying, all right, T1 has these 3 elements. T2 has these 2 elements. I want to take our first list and add the 2 elements from D and E to the end of it. When I print T1, it has now been modified, but our second list is still the same. It's still there and it hasn't been changed. We're essentially just taking a copy of it and adding it to the end of T1. The original still stays the same. Okay? Now, the sort method arranges the elements of the list from low to high. Palooza says these methods do mutate, right? Yep, and that's what we're seeing right here. So since we're calling extend on T1, calling that method literally has now mutated T1 to have more elements. The original T1 has been changed. The original has been mutated. And so, same with append here, right? We're taking this T list, we're appending an element to it. It's now been mutated and it contains 4 elements. Okay? Sort method arranges the elements of the list from low to high, sorting numbers, letters, etc. Just does a sort. Pretty self-explanatory, I think. But notice here that we don't pass in any arguments to to this method. It doesn't require any. Now, I imagine that, if you wanted to sort one way or the other, there's additional arguments that you could pass in, but by default, it's going to sort low to high, and we don't need to pass anything in order to do that. So sorting, alphabetically, we don't need to pass anything in order to do that. Another thing to note here, most list methods are void. They modify the list and return none. So that's important to remember. They modify the list and return none. If you accidentally write t equals t dot sort, you will be disappointed with the result because they don't return anything by default. So if I wanted to print, the sorted version of t, I can't just say print t dot sort. I have to do the sort operation first, which doesn't return anything. And then I have to print t itself after it's been modified. So this is important to remember. And I think we'll talk about this again, but you might not quite get it just yet. But as we've talked about in previous lessons, there's a difference between returning something and not returning something. And not every function or method is going to return something, even though it can still do an action, right? This method is still doing something. It's sorting T, but it's not returning any value. Okay? Yeah, let's demonstrate. So, okay, we'll take T here. Well, so we'll do this one. We'll take this one. No, I'm going to do I'm going to do sort. Yeah, we'll do this. T, that there. So I've declared T as DCEBA. We'll do, first we're going to do it just kind of as is. So T.sort, and then we print T, and we get something back, right? We're able to print it. Now let's do print T.sort. Yeah, so see the difference. We can't do print T.sort because sort does not return anything. When I call that method on T, it returns nothing, none. However, T is still there. So when I print T, it prints the sorted version of T. Yeah, exactly. And this is, I'm harping on this a little bit because it actually has tripped me up before. I was thinking, oh, I can be more efficient if I, just say, all right, I want to print this and sort it at the same time. And nope, doesn't work. It did still sort. That's exactly right. It sorted, but nothing was returned. Yeah. All right, so we're going to take a break. I think we're about halfway through. So we're going to take a break. And when we come back, we are going to start covering some more advanced stuff like deleting elements, rearranging things, that type of thing. And then we're going to do some exercises to test our comprehension of what we just learned, because this is a lot, right? This is a lot. There's a lot going on here. There's a lot we can do. There's more that we can do with lists than we can do with strings. There's a lot of things you can do with strings, but if we want to do more advanced stuff, if we want to, mutate stuff, we need to do it with a list, because lists are mutable, strings are not. Yeah. And Melod, see if you're still here. When we come back, we'll just talk for a couple minutes on handling pressure in sprints. All right, so we're gonna take 5 minutes. So please get something to drink, get up and stretch if you're able to do so. Make sure you're moving around. There was just a study that came out that said basically the best thing you can do for yourself, for your health, when you're working a job like coding or anything that's kind of sedentary. There's always like, oh, everybody should have a standing desk, right? Or everybody should have an ergonomic chair, and those are great. Those are fantastic, but staying in any position, whether you're sitting or standing, for a long time is really bad for you. So make sure that you are moving your body. I am standing here. When I'm moving my body, I'm bending my knees, occasionally, and then on every break, what do I do? If I'm standing this entire time, so what do? I go and I sit down. I sit on a couch, just to move my body in a different way. All right. So take 5 minutes, move around a little bit, and then when we come back, we're going to learn more about working with lists. Oh my goodness, just popping back on really quickly to say thank you so much, Kadavari, for the subscription. I really appreciate that. Thank you for using your Prime sub. Good to have you here as always. Alrighty, folks, we got about a minute left in the break, so please come on back if you're coming back. Remember, if you've just been sitting this whole time, please get up and move if you haven't already. Hey, welcome to the stream there, Buit. And as always, please pet your dogs, pet your cats, pet your significant other with their permission, of course, and then come on back. All right, is it working now? We had the little, I had to flip my microphone from one microphone to the other and then back, and now I think it's working. Okay, good. So the mic issues continue. That's fun. Yeah, as I was saying though, Trillium, I did not make the graphic. I got it from Streamlabs. So they have some great graphics that were made by some very talented designers that you can purchase. And so I did that one because it was the only one with a wolf in it. I just wanted one with a wolf in it, and that was the only one. And I think it's pretty nice. It looks a little bit like that game Firewatch. So it's a very pretty graphic, I think. All right, welcome back, everybody. So we're going to continue talking about array methods, and I can say array again because the ban is over, but I'm going to try to say list. So list method. That's really hard to say. List methods. But before we do that, I just wanted to touch on a question that a first-time chatter asked prior to the break. They said, Melodzi asks, how to handle pressure in Scrum sprints as a Java developer. Now, I'm not a Java developer, but I am a developer. I do back-end work in my day job. So how do you handle pressure in Scrum sprints? I think the best thing that you can do is to make sure that your sprints are reasonable. Make sure that the burden of work that you're being assigned in your sprint is reasonable. Now, if you're following agile principles, one of the first things that you do when you're dividing up the work for a sprint is you assign it a point value based on your ability and the amount of work it's going to take to finish that thing. So each person says, I have X points available in this sprint. You know, I'm going to be out for 3 days during the sprint, so I'm going to reduce my point total by a couple. And then you only get assigned the amount of things that fill up that point total, right? So you can get assigned, let's say I have 5 points in a sprint, I can get assigned 2 2-point items and 1 1-point item. And the point value of those items depends on how hard they are for you. Not how hard somebody else thinks they are, but how difficult they are going to be for you, or how much time it's going to take for you to get those things done. So from the start of the sprint, the amount of things assigned to you should be reasonable based on the amount of time you have, your existing workload, and your ability, right? So it's theoretically, in a perfect world, it would be reasonable, you know, and you would be able to get everything done on time. However, that's not how the real world works, right? A task might suddenly become more complicated. The customer might change their requirements. There might be an issue that you couldn't have known ahead of time. You know, you might have to take a day off because you're sick during a sprint or something, and that changes the equation. And so if you're feeling the pressure to get things done on time, then you should be letting your manager know, or asking your coworkers for help. Or some people have scrum masters that manage their sprints. We don't, so I don't have experience with that. But you should ask the person who is in charge of divvying up that work, or managing that work, or managing your scrum board, your Kanban board. You should ask them for help. Say, hey, does anybody else have capacity to take this item? I'm suddenly not going to be able to get everything done. So the best way to handle that, if you're in the sprint and you're feeling pressure to not be able to, get everything done on time, you don't think it's going to work, then you need to communicate, whether that's with your coworkers, with your boss. And if they are consistently forcing you to take on more work than you can physically do in a sprint, then that's their problem. That's an organizational problem. That's them not doing this correctly. The whole point of doing sprints and agile and sprints is that each person should have the amount of work that they can comfortably complete in that window of time. Okay? And if you're new, it might feel uncomfortable to ask for help, but that's the best thing that you can do, is to say, hey, I'm struggling with this. It's taking me longer than I expected. And, I need some additional help with this. Can somebody have some time? Hey, Trillium, great to see you. Yeah, have a great rest of your day. Icefire says sprint. Are we running? No, sprint is a common term in software development. It refers to a period of time where you're accomplishing some specific tasks. So generally it's like a very small part of a project, like one component of a project. And generally they are set time blocks. So they might be 2 weeks, they might be 3 weeks, but by the end of that time period, you are expected to have a set list of items completed. And you know those items going into that 2-week period. You know what they are, they're assigned to you. And then by the end of that period, they're done. Silly says, if you're in a new work environment, some people may pressure test you and see where you push back. Yeah, that's a crappy way. That's honestly really crappy. I wish that didn't happen. But, again, the best thing you can do if you're new is speak up for yourself and say, hey, I want to get this done. It's been assigned to me. I want to see this task through, but I need some help to figure out what I'm going to do so I'm not spinning my wheels and wasting time. Or you might say, this is too much for me to do right now. I want to get my work done right. I want to give you a good product. So does anybody have availability to take 1 or 2 tasks? Yeah, exactly. Communicate before the time is up. Communicate as soon as you know there's a problem. Yeah. So I hope that's helpful for you. That's just kind of some real work type stuff that you are probably going to encounter at one time or another. If you're working in a team software development job, it's something you will encounter. So just know how to communicate, know how to speak up for yourself, ask for help. And that'll help everybody get everything done on time. Okay, so before the break, we talked about list methods. So we talked about adding things to a list prior to the break, right? We talked about append, we talked about extend, and we talked about sorting. So this is kind of just adding things to a list or shuffling them around. But we can also get rid of stuff in a list as well. There's a couple different ways to do that. We can use pop if we know the specific index of the element that we want. So in this case, if we call the pop method on our list here that contains A, B, and C, we can call pop and say we want to pop the item at index 1. And when we print T after that, we can see that the item at index 1 is gone, and the list now just contains A and C. Now, notice the second part here. When we called the pop method, we were able to take the item that we were popping and assign it to a new variable, and then we can print the item that we popped. So essentially, pop modifies the original list and returns the element that was removed. This is important. Pop is a method that is not void. It actually returns something. It returns the element you're popping. So you can kind of think of it as like you're popping it up in the air, and then you can catch it, and you still have it. You don't lose it. It's still there. You can print it. You can do something with it, but it's been removed or separated from the original list. I kind of think of it this like Pringles, the chip or the crisp. Their slogan is "Once you pop, you can't stop." So what do you do when you open a jar of Pringles, right? You pop the lid off. That's very common. You know, people say, I'm going to pop open a jar of Pringles. It's literally their slogan. You pop off the lid. However, you don't want to get rid of the lid, right? You keep the lid. You still have it. You're popping it off of the jar of Pringles, but the lid is still there because you're going to need to put it back on later. So you're saving the lid, and you still have both elements. They're just separate now. So that's how you can that's how you can remember what pop actually does. It separates that element out, but you still have it and can use it for other things. Okay? However, maybe you just truly want to get rid of that value. Just blitz it from existence. In that case, you can use a del statement. Now, what do you notice about del? Just looking at this, what do you notice? Look at you know, the other look at some of the methods we've covered. And what is the difference between del? What's the difference between del and some of those other methods? I'll put both pop and del on the screen here. What do you notice? Icefire says no return value. It's a good guess, but a lot of the other methods that we looked at don't have a return value either, right? Append doesn't. Append doesn't return anything. Sort doesn't return anything. Tej says del is destructive. Technically, yes. Machine says it is like a keyword. Yeah, it's not a method, right? Look, it's not a method. Look at it. It's not a method. It's different. Notice how it's called a statement here. It's not called a method. It's a statement. Yeah. So just notice here, be careful. This is actually not a method. It still does something, but it's a statement. Now, we haven't encountered specifically like the definition of what a statement is, but I'm just treating it kind of like a declarative statement. Like, hey, this is a keyword and it does something to the thing after it. But yeah, just note that difference there. So if we try to call like t.del, then that wouldn't work. We have to call it del and then the item that we want to remove. Now, I don't know why these are different, but we should note that they are for now. Inza says, what's the difference? Well, methods are kind of like built-in functions that are built into the object type we are calling them against, right? So lists have a set of built-in functions. Strings have a set of built-in functions. And anytime you're referencing those, you call it with, all right, so like object and then dot and then method. And that's saying, all right, I want to access this pre-built list of special functions that can only be used on this object type. Now I'm imagining, I don't know if this is true, but I'm imagining that del could be used against a variety of different objects. Like, but I'm not sure because again, I haven't encountered this before and the text doesn't say for sure. Yeah. And that's what I was envisioning, Iced. They say, interesting. You can even use del to delete a variable. Yeah. What I'm imagining is that the reason del is configured this way is that you can call it against a variety of different things. You can call it against, variables, like Icefire said. You could call it against a specific index in a list. So it's very flexible, I guess, in that regard. So methods are limited generally to a specific data type, but del seems to be, you can use it against whatever. I'm sure there's limitations, but that seems to be the difference. Yeah. So essentially, but del, in the context of a list, del works similarly to pop, but the difference is it just discards whatever you're getting rid of. So in this case, we're deleting the item in index 1 and it's just gone. Straight up. So that'd be like if you open up your Pringles can and you just, frisbee the lid out the window or you burn it. It's gone. Now, if you know the element you want to remove, but not the index, you can use the remove method. Now, this is a method. Note the syntax here, t.remove. This is a list method. So it's a specific type of function that's limited to use in list type objects. So here we're saying, I don't know where B is in this list, but I know it's there. And so I want to remove the value B. We don't have to reference an index. We're referencing a value here. But the effect is the same. Also, too, notice that we're not returning anything here either, right? We aren't saving this value. We're just getting rid of it. It says, all right, there's B somewhere in here. I don't know where it is. Just get rid of it. And it says here, the return value from remove is none. It doesn't return anything. It just does the action and stops. Now, oh, thank you so much for the follow, Dettol Skincare. Thank you so much for the follow. So to remove more than one element, you can use del with a slice index. So that will get rid of everything in this slice. We're saying, all right, I want to delete something. And the specific thing I want to delete is this slice from items 1 through 5. And then when I print what's left of T, all that comes back is A and F. Skincare says, are you learning Python for the first time? Yes, I am. Yep. I'm a data engineer, and I thought learning Python would be super helpful for my job. And so I'm going through this wonderful Python for Everyone course that's free. But as I was, wanting to learn Python, I thought, hey, it would be even better if everybody else in chat learned Python along with me. So yeah. Are you already a Python expert, Skincare, or are you just learning Python too? Because if you're just starting out, you're welcome to also check out the previous streams in this sort of series that are on my in my Twitch archive. But yeah, welcome to the stream. It's good to have you here. Because yeah, the best way to learn is by teaching, right? So best way to learn is by doing and teaching at the same time. And so this is why this has been extremely helpful so far. All right, so let's talk about lists and functions. Oh my goodness, Silly, thank you so much for the follow. Silly AU. There are a number of built-in functions that can be used on lists that allow you to quickly look through a list without writing your own loops. So note the difference here. Before we were looking at methods, but now we're looking at functions. And these functions can be used against a variety of data types, against strings or lists or, a variety of things, right? Kind of like how we can call print against anything that can be printed. We can call something like length, max, min, sum against anything that can be, have a length, be maxed, min, summed, etc. And since a list, it does have a length, it does have a maximum value, it has a min, it has the ability to be summed. All of these built-in functions can be called against our list. So what we're doing here is we're just saying, all right, get the length and print it, get the max, get the min, get the sum, or we can also do, arithmetic too, just like we saw previously, with, doing so, when we first introduced these built-in functions, you're able to use the function and then do some additional operations prior to printing it. So here we're taking the sum, which was 154, and then we're dividing it by the length, which is 6, and I'm just going to take their word for it that is correct. I can't do that kind of math in my head, but I'm going to assume it's fine. All right. Define says, what are your main languages? So what I do in my day job is I am a SQL developer, data engineer. So I primarily work with SQL. I also, in my day job, I also work a little bit with C#. If I'm working on desktop applications, like internal applications, I'll use a little bit of C# or a little bit of Visual Basic. Super fun. I have to maintain some legacy applications that were built in Visual Basic, so I have to do a little bit of that as well. Yeah, SQL, Visual Basic, C#, a little bit of, occasionally a little bit of TypeScript for Excel macros. But on the weekends, I teach with 100 Devs, which is a nonprofit that helps folks learn how to code from scratch. And so for that, I primarily work with the MERN stack. So we're talking JavaScript, we're talking MongoDB, we're talking Node, Express, and React. So for a lot of the lessons, if you look at my YouTube archive, a lot of what you'll see is MERN stack stuff. So primarily JavaScript on the weekends. But again, for my day job, I use, SQL and SQL, C Sharp, that type of thing, really back end languages. But for the stuff that I teach, you'll see some of that. I have some courses on SQL, and I did a course on C Sharp too. But primarily, it's going to be MERN stuff. Yeah. BBD says VB old school. Yeah, that was not my choice. Yeah, that was not my choice. We had somebody on our team who incredibly skilled coder, like just could visualize things, could architect entire applications, incredibly brilliant. Unfortunately, his major stumbling block was that he felt like Visual Basic was basically the last language he ever needed to learn, and that it could do anything and everything, and it was fine for anything. Like, it was just, that's all he ever needed. So he built everything in Visual Basic and refused to learn C Sharp. Like, I asked him once, I was like, hey, why don't you pick up C Sharp? And he was like, nope. I'm like, okay, you built the stuff. And so, he was building stuff in Visual Basic up until the day he retired. And then, of course, it fell on me that I have to start maintaining it. So, it was sold that way. Yeah, and that's the thing. He was very much old school in that regard. Visual Basic was sold as like, this is the last language you ever need to learn. It's the best language you can ever learn. And, he kind of bought that, hook, line, and sinker. And did it work? Yeah. But does it make it really hard to maintain stuff? Also, yes. So you have to think about that, when you're choosing the best, when you're choosing the right language for your project. Think about future maintainability also. Especially if you're building a project for a group, think about, hey, is this really the best way I could be doing this to allow others to maintain it in the future? And so since then, I've written all new applications in C#.net. But the old stuff, it's going to take forever to rewrite it. I'm going to rewrite it in C# eventually. But so he used Visual Basic and like .NET 4.0 or something, which is both of those things are really no longer supported by Microsoft. So both of them are, out of support. And yeah, it's not great, but they work. So they'll work until they don't, right? They'll work until they stop working. But everything new I've built in C# and the, current version of .NET. So I'll get around to it when, when I can, but that's not my primary role at work either. So I'm only able to work on those applications when I have time after getting everything else done. So that means really slow progress. T says, how is the C# learning curve for you? Not bad, because I already knew JavaScript. That's the great part. Once you know one language, you will have a much easier time learning your next one. So I already knew SQL and JavaScript. And so I started looking at C# and I was like, hey, this looks familiar. This looks like JavaScript. And so, just having that baseline knowledge made it so much easier. And I was able to whip up, a C# application within a couple of weeks of, first picking it up. Silly says, but today's best choice will not be the future's best choice. Absolutely. You're 100% correct. So you can only, but my suggestion is that you pick the best thing that you can, right? In this particular case, this person was building things in Visual Basic, even with knowledge that that was no longer the best choice, like building new things in Visual Basic, even though, there were all these constraints and things that, I been urging him to maybe, hey, can you maybe build it in C# or something newer? And he was like, nope. I'm like, okay, guess that's what we're doing then. So, you just have to kind of take the information that you have and make the best possible choice. TV Josh says, sounds like a shitty dev. I wouldn't say that. No, he did a lot of really helpful things and things that helped the team a lot. So, I can't say that. I can say that he was maybe a little bit stuck in his ways. But hey, I might be that way too when I am 2 years from retirement. So who knows? Yeah. But yeah, we can just the best thing we can do is be flexible and open to new information. And that's going to make us be better developers. Ice says that's the language he knew. Yeah. I mean, that was, and that's all he ever wanted to know. So, I think that what's important, again, and that brings up another point, right? Is that the larger you make your toolbox, the more information you're open to, the more information you pick up, the more things you play around with, the more of a palette you'll have when you have to go build something new, right? You'll be like, oh, I could choose from this, or this, and I think this thing is the best, right? You can say, I have a bunch of things to choose from, and this is the best option with the information I have. You're not limiting yourself artificially. Yep. Boo it. Thank you so much for the follow. All right, let's get back to it. So we were just talking about how you can use built-in functions, things like max, min, sum, etc., on lists as well. But the sum function only works when the list elements are numbers. However, the other functions, max, length, etc., work with lists of strings and other types that can be comparable. So the difference here is that sum is strictly arithmetic, right? It does arithmetic. You sum something by adding numbers together. But these other functions, max, length, etc., they just work with anything that's comparable. So with this in mind, we can rewrite an earlier program that computed an average of a list of numbers entered by the user using a list. So this is our original program here. We're saying, all right, we have a total value and we have a count value, and essentially keep looping and keep asking for input. So it's just going to keep asking for input, asking the user to enter a number. If they enter the value done, then stop the program. Otherwise, just keep looping forever. That's why this says while true, right? This is going to be an eternal loop until the user enters the word done. Now, we convert the input value to a float. We increase the total by adding the value. So this is keeping like a running total, right? So total keeps getting the next value added to it, and our count increases by 1 for each loop. Then the average just becomes the total divided by the count, and we print that average. So we can kind of see this as a very manual way to do it, right? Given the information that we have now, we could use something like the sum function. I believe we did this problem originally in one of the previous streams, and the instructions specifically said, do not use the sum function. So we had to do it without using the sum function, but now we can actually use the sum function and simplify this program. So we're still going to need, our loop, right? Because we're still going to need to keep increasing that total value. But now we can declare an empty list and keep adding to that list as we loop. So, all right, we have a list here, it's empty. Keep looping forever, ask for input. If the user enters the word done, stop. Otherwise, convert the value to a float and simply append the new value to the end of our list. So we're just keeping a running list of every single value the user has ever entered. And then finally, after the user enters done, we break the loop and we compute the average using the built-in functions. So that just becomes the sum of the entire list. They're all numbers, right? Because we've converted them all to floats. So a list of numbers, take the sum and simply divide by the length. The list keeps the count for us, right? Because we can just use the length function to find how long that list is. And then we print the average. So I'm going to pause here for a second. Anybody have any questions about what we just talked about here? Now we have some new people, so it's perfectly fine to ask questions, and there's no such thing as a stupid question or a silly question. Okay? You're allowed to ask questions, and you're allowed to say, I don't understand as well. That's a valid thing to say too, because that just means that I need to maybe explain something again or explain something a different way because maybe I didn't explain it the best the first time. So feel free to speak up if we're confused. But essentially what we're doing here is instead of having to keep the count ourselves and increment it by 1 for each loop, and keep the total ourselves with a running total, we can use the built-in functions instead to first build the list containing every single value the user has entered, not do any calculations on it yet, just keep the list, keep a ledger, right? And then compute the average when we have all the values. So once we have all the values, the list is complete. And then once it's complete, then we do the calculation to calculate the average. Okay? Cool. So let's talk about lists and strings. As somebody asked earlier, what's the difference? You know, we talked about one difference. What's the first difference we talked about in terms of lists versus strings? What's probably the biggest thing? What's one of the main differences we've already talked about between lists and strings? Also, if you're new here, I occasionally ask you questions, chat. What's the difference between lists and strings? The main difference, the thing that we have to be careful about when we're working with lists. Where's my tea? Oh, it's over there. Yeah, we have immutable versus mutable. So what are strings? Are strings immutable or mutable? Are strings immutable or mutable? You have two options, 50-50 chat. So even if you weren't here for the start of the stream, you can take a guess. Yeah, exactly. Strings are immutable, meaning that a string, once it's created, cannot be changed. Now, you can create a new string that's an edit of the old string, but the old string will always be there. So if you want to, let's say you have a string, let's say you have the word Mayan Wolf, right? And you want to capitalize the M in Mayan Wolf. Well, what you would need to do is create a new string with the first letter capitalized and all the other letters left lowercase. So the original string with the lowercase, that's all lowercase, still exists. And then the new one has the capital M and all the other lowercase letters. And then that's what you would return. Now, lists are mutable. They are changeable. I am me. Welcome to the stream. Good to have you here. Yeah, now lists are mutable, as we've seen, right? You can take a list and change it directly. You can slice and dice it, rearrange it, and the original list is now different. So if you want to make changes to a list, especially destructive changes, it's advised to first make a copy of that list and then change it, because the original is being changed, and once it's changed, that's what it is. The original configuration is gone because it has been edited. So very important distinction and important to remember. Yeah. So now we're going to talk about some sort of holistic differences between lists and strings. A string is a sequence of characters, and a list is a sequence of values. But a list of characters is not the same as a string. So let's pause there for a second, and because there's a lot of vocabulary that was thrown around there. So we got to really understand that sentence. So a list of characters, so like this, a list of characters is not the same as a string. So this is a list of characters. This is a string. So we can very kind of clearly see the difference when it's printed out for us here, but just reading that might not make a lot of sense at first. So essentially, a list has some shared characteristics with a string, but the two of them are different things. Okay? Now, to convert from a string to a list of characters, you can use list. So we're taking the word spam here. And remember, strings are immutable. So we're assigning a new variable here, and we're calling list. And then when we print our list, what we have is now a list with each of the letters in spam as a separate list element. So list is the name of a built-in function, and you should avoid using it as a variable name. So that's, you should avoid the letter L. I mean, I don't like to use single letter variables unless I have to. Unfortunately, this course does a lot of that. They do a lot of single letter variables. I don't generally like that. I think you should try to make your variables as descriptive as possible as to what they're actually doing. And what's funny is the course actually talks about that at the beginning. It's like, make descriptive variables, and then the course just uses single letter variables like throughout. So I don't know why it does that, but just remember that you can make your variables more descriptive if you want to. Anyway, the list function breaks a string into individual letters. If you want to break a string into words, you can use the split method. So list breaks a string into letters, and split breaks a string into words. So that's a little bit different than JavaScript, right? If you're coming from a JavaScript perspective, you would call split to basically separate a string in any form, but you would pass in the delimiter that you wanted to separate it by, right? So if you wanted to separate something into words, you would pass in the delimiter of space, right? And if you wanted to split it into letters, you would just pass in an empty string as your delimiter. So Python calls list for individual letters and split for words. So if we take Pining for the Fjords, split it apart, that gives us the individual words. Now, if we called list on it, it would separate it out into a much longer list of all the individual letters. Okay? So something, a little syntax difference to remember there. Just be careful. And then once you've broken it up into a list, you can do all the array stuff against it, right? You can look at specific indexes. So, I could take a long string, split it up into its individual words, and grab any index that I wanted. Now, let's say I have a very long line of text. Why might I want to split it up into a list? Why wouldn't I just say, all right, I have a really long string, I'm going to grab an index value? Because you can do index references directly on strings, right? Why do I want to split it up into a list first? Think about this example. Why did I want to split this up into a list prior to grabbing the index value? Why wouldn't I just leave it as the original string if I can do exactly the same thing against a string? Why would I put it into a list first? A string is immutable, that's correct. But in this particular example, I want to let's break it down a little bit. In this particular example, I want to take this string and return the word the. Why wouldn't I just grab an index, pass in a string index directly? Why am I converting it to a list first? Yes, exactly, Shahid. We can't access the whole word directly, and it's much easier if I want to do a direct index reference like I'm doing here. If I want to say T2 to return a whole word at once, I have to split it by spaces first, right? I have to split it up into the individual words first before I can access it directly with this index value. So just to illustrate that, let's do it really quickly. I'm going to set up this string. S equals Pining for the Fjords, right? And then if I want to find the value, let's say, okay, I want to try to return the word the, so I'm going to say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, S 11. Oh, that just brings back T. Well, I mean, technically I could do a slice, right? But I have to know how long the word is. Now, I know how long the word the is, which makes it a little easier, but I have to say, all right, 11, and then 12, 13, this is going to be S 14. All right, that brings back the, but I had to first count every single letter and every single space to find the value, the index value where I even wanted to start. And then I had to know exactly how long the word was to find the exact length of the slice. It's much easier if I split it into an array first, and then I can just say, well, there's 1, 2, 3, 4 words in this string, and I know that the one I want is at index 2, and I can just do a direct reference like this, T2, get me the third word. So it's just a much easier way of breaking this up into chunks. Now, why does that matter? Why do we care? Why might we want to do this if we're working with real files? Why do we want to split stuff? Why do we want to perform this type of operation if we're working with real data? Why is this important? I'm not angry at you. Welcome to the stream, by the way. To get statistics, sure. To clean up things. In a more general sense, though, if we're working with real data, we often can't look at the data directly, right? We might not be able to look at the data directly. We might not know how long the word is that we're looking for. We're going to have a lot more unknowns when we're working with real data, right? So wouldn't it be easier if we can split it up into words and we already know the delimiters? And in this case, it doesn't matter how long each of the words are, right? These words are all different lengths, but we don't care. We can just return the word at a particular location. It doesn't matter how long it is. We don't have to compute the slice length, right? And as Sindlead mentioned, technically you can do that, but I mean, is that made like look at the complexity of that? What Sindlead put in chat there. Look at the complexity of that. Instead of just converting it to an array of words and then finding the word at a particular location. Doesn't matter how long it is. All we need to know is, in general, where the word is located in the list. So much easier as you start working with longer strings. If all you care about is the individual words, rather than trying to parse it as a string, let's convert it into a delimited list and then just grab the individual words. Kamikaze says, for the performance, yeah, I imagine that could be a factor too. As you start getting into very large files, you're going to have to, think about how long exactly do we want this list to be? How do we want to slice things up? How do we want to break it up? Yeah. But yeah, I mean, all those things are considerations once you start working with real life data. B-chan, thank you so much for the follow. Good to have you here. Oh my goodness, Eric B, thank you so much for the sub. I appreciate you. I'm trying to get my thing to show up here. There you go. There's my little subscription pop-up. It doesn't work on its own. I have to trigger it. But thank you so much, Eric B. Good to have you here. Thank you so much for subbing. Also, as a reminder, folks, if you are subscribed to Amazon Prime, please do use your Prime subs. Don't let those go to waste. I don't care if you use them on me. I never ask for that, but use them on, your favorite streamer, because those are free for you. You don't have to pay anything. And it's a great way to, to spread the love a little bit and cost Jeff Bezos some money, because Jeff Bezos, God knows, he needs to spread his wealth around a little bit. So let's make Jeff Bezos spend a few dollars on people creating quality content. But yes, thank you again, Eric B. Good to have you here. Alrighty. So we've used split to break the string into a list, and we can use the index operator to look at a particular word. And you can also use a custom delimiter. So in this case, we can specify a specific delimiter and how we want to separate this string. Now, by default, split is going to use a space, because in a multi-word string, the most common delimiter is going to be spaces, but that's not always going to be the case. what might be a case where you might have a different delimiter? What might be a case where you have a string and you want to separate it out into individual words, but you wouldn't necessarily have spaces? I'm actually looking at an example right now. CSV files, maybe, yeah. Even a simpler example, your usernames that I see in chat right now. A lot of them are a bunch of words put together. But for example, Shahid's username. If I wanted to separate that out into 2 words, I don't have a space, but I do have a different delimiter. I have an underscore, right? If I wanted to separate that out into 2 different words, Shahid underscore Mufakir, then I would need to define my delimiter as the underscore rather than a space. Yeah, and as Les mentioned, in real data, sometimes you're not going to have spaces. Maybe the source system just doesn't work that way, right? The source system is going to say, nope, I don't put spaces between anything. I'm going to use quotes, or I'm going to use commas. I'm going to use tildes. I don't know. I could use any character. Source systems are weird. So we can pass in a specific delimiter into the split method and split something a different way. So if I wanted to split, if a username has 2 distinct words and I want to split them into 2, then I can define my delimiter as a hyphen or an underscore or whatever it is, and I end up with a list of those individual words. But again, by default, split is going to use spaces. Now, just like in JavaScript, join is the inverse of split. So we split something apart into individual words. Generally, we'll do, some kind of a transformation on that. You might want to capitalize those individual words, right? And then you can join it back together using the join method. And when we do that, you'll notice that join puts a space between the words. And so that's because what we've done here is we've said, all right, our delimiter is going to be space, and we call the join method against the delimiter. So that's a little bit different than in JavaScript, right? In JavaScript, you would say t.join, and then you would pass the delimiter in as the argument, right? So just to illustrate that, I'm going to I'll put it down here. So in JavaScript, we would say something like t, which is our array, or our list, sorry. Well, in JavaScript, it would be an array, right? In JavaScript, we would say t.join, and we would pass in, let's say, a space, right? And that would take our array, and it would join it with that space as a delimiter. In Python, it's the opposite. So have fun with that. Have fun with that if you're already familiar with JavaScript. I know I'm going to make this mistake probably, 12 dozen times. Oh my goodness. Thank you so much, Silly AU. Thank you so much for the sub. Good to have you here. I appreciate you. Codeplex, welcome to the stream. They say the JavaScript way makes way more sense. Yeah, yeah. It's a little funky. The first time I read this, I was like, what is happening here? But yeah, so in Python, it's the opposite. You take your delimiter value, and you call the join method on the delimiter, and you pass in the thing you want to join as the argument, right? It's like, what? Why would you do that? But anyway, unfortunately, it's what we're stuck with. And so we'll just need to remember that when you're joining things together, it's the literal opposite of Python, or literal opposite of JavaScript. I says Python's a bit confusing at times. Yeah, it's an interesting trade-off. I've already found some things that I like better in Python than JavaScript, and some things that I very much, like better in JavaScript than Python. So for me, it's been about, an equal, equally weighted so far. Yeah. And that's what you get with any language, right? You're going to get things that are, because, most languages are developed kind of independently of each other. They grow independently of each other. And whoever is building the language is going to have certain opinions on what makes sense for them. And unfortunately, what makes sense for one person is never going to be, what makes sense for the other person. So oftentimes we're a little bit constricted by the original creator of the language and what they thought made the most sense. There's some fun choices about that. Hey, Bound, thanks for being here. Got your watch streak going. Nice. All right, so to concatenate strings without spaces, you can just use empty string as your delimiter. Again, similar to JavaScript there. Now, let's talk about actually working with lines, working with files, working with strings that are longer than one line. How do we parse an entire file's worth of data? And usually we want to do something to the lines other than just printing them. Oftentimes we want to find the interesting lines and then parse the line to find an interesting part of it. So take this line here. If we wanted to print the day of the week from the lines that start with from. So the first thing we can do to handle this is we can call the split method. We're going to look for any line that starts with from, and we're going to take that line and split it using the spaces as the delimiter. And so what we'll end up with is a list with 1, 2, 3, 4, 5, 6 values, right? Because this is going to be treated as one single value because it has no spaces. And so this email address is going to be treated as one single element of the array. So that's what we're doing here. We're opening a file. We're taking each line. We're stripping. Well, I guess I'll ask you, what are we doing here? What is this doing? We're taking each line in the file. And what are we doing with it? Line equals line.rstrip. What does this do? CodeBlex says, I'm bothered that in Python it's not even consistent. Join versus split. Yeah, exactly. I know. I noticed that too. Yes, even performing split and join are not opposites of each other, like in terms of they aren't equal in syntax. They're the reverse of each other in syntax, which I'm like, why would you do that? But yeah, what is rstrip doing? Yes, as Silly mentioned, it's removing spaces from the right-hand side. Why are we doing that? Does anybody know? Why do we care about that? Why do we want to remove the white spaces from the right-hand side? Onoseto, thank you so much for the follow. Good to have you here. Why do we want to remove why are we worrying about this? Why do we care? Why are we doing an rstrip here? We don't need white space as part of a word. Yep, totally legit. Yep. Remember, okay, let's ask this. How does Python know when it's reached the end of a line? As Python is looking at a file, how does Python know when it reaches the end of a line? Yeah, line breaks, right? And if we want to manipulate, VR says default is 80 characters of a line. Yeah, I think, but in this case, that shouldn't matter. This is just gonna handle white space. But yeah, when Python reaches the end of a line, it uses a new line character, right? And we don't want to carry that through. We don't care about the new line characters because what does print do? What does print do by default? VR Mechatronics, thank you so much for the follow. It's good to have you here. What does print in Python do by default? Yeah, it prints on a new line, right? And so depending on what we're doing with these lines, you could potentially end up with a double line break when you print it. Now, in this case, we're not printing the whole line, but you could eventually end up with double line breaks if you print the whole line and the print function adds a second new line at the end. And we don't want that. So we want to just get rid of any extra white space on the end of the line. We're going to handle that with print. And then what are we doing? We're saying if the line does not start with from, then continue. What does continue do? Hey, Asex, welcome to the stream. Good to have you here. What does continue do in a loop? Doing a little active recall here, folks. What does continue do? Yeah, it jumps to the next iteration of the loop, right? We don't stop the loop. We just stop this iteration. We don't do anything past this, and we go to the next. And that's because we're saying, hey, if the line does not start with from, we don't care about it. We don't want to do anything else with it. We just want to move on to the next line. Yeah. MJ1313, thank you for the follow. Good to have you here. So if it does start with the word from, then we say, okay, we want to work with this line. We're going to split it out using spaces as the delimiters. We've gotten rid of any extra white space on the right. Get rid, split by spaces. And then we want to print the word at index 2. So since we're going for the day of the week, and each of those lines is going to be formatted the exact same way, I can say, all right, I've split this line out by words, and I want to say 0, 1, 2. That's the day of the week. And so when I run this, it's going to print out Saturday, Friday, 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 blah, 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 blah. Because it's going through the file, finding every single word that, every single line that starts with from, splitting it out into a list, and printing the word at index 2. Hi, MJ. Good to have you here. Okay. So right now, this could be a little bit crude, right? What if, for example, not every line with an email address starts with from? What if from is sometimes formatted with a semicolon or with a colon and sometimes not? How do we always make sure we're getting the right line? Well, they say later we're going to learn increasingly sophisticated techniques for picking the lines to work on and how we pull those lines apart to find the exact bit of information we're looking for. What do you think that's hinting at, chat? What do you think we might be learning? What's a more sophisticated way of working with strings? You know it and you love it, chat. It's our best friend. I say that sarcastically. What's a more advanced way of working with strings? Wearing a suit? Sure. What's an advanced way of working with strings that you can use in multiple languages? Regex. Yes, our friend regular expressions. Regular expressions in Python often go hand in hand because it's a really quick way to do very detailed and precise work with strings, right? You can set up a regex expression to do pretty much whatever the heck you want with a string. And so that's what we're going to cover later. Yeah, regex. Regular expressions. Yep. All right, let's see where we're at here. I think we should probably take a break, but I just want to see. Yeah, all right, so we've got a few. Yep, so we're almost to the end here. So we're going to take a break now. And then when we get back, we're going to get into a little bit of theory type stuff that's still important to know. But a little bit more high concept. So it's a good time to take a break, refresh yourself, get something to drink, stretch, percolate on any questions that you might have. And then once you feel refreshed and ready to take in some new information, we're going to come back and learn about the difference between objects and values. Cellophane says rhymes with FedEx. Yep, regex and FedEx, exactly. MJ says, do you also teach C? No, I do not. However, there's another course by this very same instructor, Dr. Chuck, and he teaches C programming for everybody. So if that's something you're interested in, apparently you have to have some prerequisite skills for this course. That's fun. But you can check out this course if you would like, also by Dr. Chuck. Same instructor. And he also has some other courses here. So Django for everybody, web applications for everybody, Postgres for everybody, and C. Yeah, of course. But yeah, I myself do not know C, so I don't teach it. But if you're interested, in learning on Twitch in a similar way to, similar streams to mine, there's a big software and game development community right here on Twitch. And I'm sure you could check around with a few streamers and see if, they know of anybody who teaches it or if they themselves teach it. Yeah. All right, we're going to take 5 minutes and we're going to take a break. And when we come back, we're going to go on to objects and values. Please do, if you've been sitting this whole time, we've been going for what, 2 hours? If you've been sitting this whole time, please do get up, move around, stretch a little bit, get a drink of water, do something briefly, do something else for 5 minutes, and then come back because that's healthy for your body. Okay? Cool. 5 minutes and we'll be right back. Alrighty, folks, we got about a minute left in the break, so come on back if you're coming back. And as always, please make sure you're getting up and stretching. Make sure you get yourself a glass of water. And as always, please pet your cats, pet your dogs, pet your significant other with their permission, of course, and then come on back. Alrighty, welcome back, everybody. It looks like my microphone is working this time. That's great. Good job, Streamlabs. Good job doing the bare minimum. It's all we can ask for. Katavari says, "What's everyone's feeling us on Netflix losing Voltron?" Oh, I didn't know about that. So the reason Katavari is asking that question is my profile picture is Pidge from the new Voltron series on Netflix. I guess I shouldn't say new; it came out like 4 years ago, but from the Voltron series on Netflix. And basically, Pidge is my spirit animal. Pidge is amazing. Pidge is the best character ever. And I didn't know that Netflix was losing Voltron. For me, it's not a huge deal because I actually don't have Netflix anymore. I chopped Netflix once the price went up to like $20 a month. Yeah, the price went up to like $20 a month, and I was like, nope, screw that. And so I gave up Netflix. Katavari, do you know if it's coming to a different streaming service? Because if it is, I might be able to watch it again. I haven't been able to watch it in like, well, 2 years probably, because I don't have Netflix anymore. So if it's coming to like Hulu or something, then heck yeah, I'm back on that train, baby. It's coming to Prime? Oh, okay, great. Yeah, I'll be able to watch it then. That's awesome. Thank you for actually and this is good news for me. I can watch it again. Yeah, I have Prime. So, perfect. Was the series good? Heck yeah. It was great. I loved it. If you go to my profile on Blue Sky, hint hint, follow me on Blue Sky. If you go to my profile on Blue Sky, my banner image is the Green Lion, Pidge's Green Lion from Voltron. Yeah. I've been wanting to watch it again for ages. No, TV, it's an all original story. And I wasn't even able to get through the original. I tried to watch a little bit of it, but I couldn't do it. So yeah, the new one is a lot better. A lot, yeah, better characters, much deeper. Yeah. They phoned it in a little bit with the ending, but you know, hey, the majority of it is good. Yeah, Hunk is great too. And great voice actors as well. Anyway, Cellophane says VS Code doesn't automatically set the correct site packages path for my, I'm assuming, virtual environment. Yeah, VS Code was a little weird for me. Yeah, I've had a few little hitches in setting up Python with VS Code, particularly because at one point I had 2 different versions of Python installed, and VS Code was like, no, I don't like that. So yeah, I eventually had to just uninstall one version of Python, and then that fixed it. But yeah. All right, let's go back to it. So we're going to talk about objects and values. So we have 2 different statements here. The first one assigns the word banana to variable A. The second one also assigns banana to variable B. I see you're on 3.12. Yeah, I know that 3.13 is out, but for the type of stuff that we're doing, it doesn't matter. You know, if it was like version 4, then yeah, I'd upgrade, but yeah, I'm sticking with 3.12 for now. Yeah, there's no harm in that. You can be on 3.12. For the basic stuff that we're doing, it's not going to make a difference. Yeah. Yep. This is all just very, you know, fundamentals that are pretty standard. As long as you're on version 3 point something, you'll be fine. All right. So in this case, both variables are being assigned to the same string, right? A and B both refer to a string, but we don't know whether they refer to the same string. So 2 possibilities. They could refer to 2 separate instances of the word banana, or the same instance of the word banana. So you might be like, what? Yeah, we're going to talk about this some more. So in one case, A and B refer to 2 different objects that have the same value. 2 different objects that have the same value. 2 completely separate instances of the word banana that happen to have the same value. In the second case, they refer to the same object. So both of these variables reference the same object. So to check whether 2 variables refer to the same object, you can use the is operator. Which one is my banana? Yeah. So we can say to check whether these two variables actually do refer to the same object, regardless of whether they look the same to us as humans, are they actually the same? So in order to check that, we can use the is operator. So here we can say A is B, and the result of that is true. In this example, Python only created one string object, and both A and B refer to that object. Now, the difference. When we create two lists, you get two separate objects. Even if they look the same, that doesn't mean they are the same. In this case, A and B are both set to lists containing values 1, 2, and 3. However, Python does not consider them to be the same thing. The two lists are equivalent because they do have the same elements, but they are not identical because they are not the same object. If two objects are identical, they are also equivalent, but if they are equivalent, they are not necessarily identical. Okay, let's think about that again. If two objects are identical, meaning they are just references to the same object, then because they are references to the same object, by default, they're going to be equivalent, right? Because if we're referring two separate references to the word banana, and I print A and I print B, they're both going to print banana. So they're going to be equivalent. But if they happen to be equivalent, they're not necessarily identical, meaning they might, these two arrays might contain the same values, but they don't necessarily refer to the same object. They just happen to look the same. Same, but different. Yeah, exactly. Yeah. And until now, we've been using object and value interchangeably, but it is more precise to say that an object has a value. If you execute A equals a list of 1, 2, 3, A refers to a list object whose value is that particular sequence. If another list has the same elements, but it's a different list, we would say that it has the same value. Hey, Exile, welcome to the stream. Hi. Yeah. So again, think about, we have to now think about the difference between an object and a value. So in this example here, A refers to the list object. So this whole thing is the object, but the elements within it are that object's value. So we could have two separate objects, as in this case, two separate objects, but they have the same value. So a little bit of a vocabulary distinction there, which can be difficult the first time you experience it, right? So that's why we spent a little bit more time here, but let's go ahead and move on, and we'll talk about some, more elements of this, and hopefully it'll start to kind of, churn in your head a little bit and start to feel a little bit more natural as to what we're talking about here. All right, so aliasing. Now, I'm very familiar with aliasing from SQL. Aliasing is something that you do very often in SQL. If I have a very long field name in a table, if it says something like user multiplication ID XJ500, that's not going to look very nice in a table. And so what I'll often do in SQL is when I query that table, I will rename it to just be user ID. And that rename is called aliasing because it refers back to the same column. I've just kind of created a new label for it. So that's called aliasing in SQL. And when we're aliasing here, we're still referring back to the same object. We just might be giving it a different name. Yeah, that's the as thing in SQL. Exactly. Yeah. So if A refers to an object, the object is the list. And then we say a new variable, B equals A. B still refers back to the same object, which is this list. And we can see here that B is equivalent to A, or sorry, B is identical to A. The association of a variable with an object is called a reference. So each of these variables references an actual object. Exile says an easy way to understand is to think of it as higher and lower order. Concept of a tree versus the empirical properties you assign to the concept of a tree, like has a trunk or has leaves. Yeah, so it's like the actual tree versus the way that we describe that tree. We can make a lot of references to a tree. We can say it has leaves. We can, say maple, but in the end, we're referring back to a tree. The tree is the object. So yeah, there's always a lot of different. My advice is, once you've kind of digested these concepts, is to come up with a mental model of some kind that helps you visualize what this actually means and how it works. That's going to make it a lot easier than just memorizing the information. And Cellophane says, okay, if we do an A equals B, and A and B have the same values in both lists, it's true. Yes, the values, that's the key word. The values are the same. And so equals is doing that comparison on values. But is checking to see whether they're the same object or not. And because they were declared separately, they're different objects. And so that check as to whether they're identical will return false. Yeah, it's an interesting little difference, isn't it? All right, so the association of a variable with an object is called a reference. And in this example, there are two references to the same object. Both B and A reference this specific list. An object with more than one reference has more than one name, so we say the object is aliased. Yeah, and that's what I was referring to with SQL. And where a column has a name originally, but it might be a crappy name, and I don't want to use that name. So when I query that column, I'm going to alias it with a new name that I came up with. It doesn't rename the original column, but it still references back to that original column. So both the original column name and the new one I give it, the new label I give it, are both aliases. They refer back to the same column. So if an aliased object is mutable, if it's changeable, changes made with one alias affect the other. So in this case, remember, both A and B refer to the same list. So if I say, all right, take item B and assign a new value to index 0, it's also going to affect A because both of them reference the same object. So in this case, it's going to print, if I say print A, even though I didn't change A directly, because A and B reference the same object, it's also going to affect A. Exactly. And in the end of all things, as Exile said, all you're doing is just assigning a name to a piece of storage space, right? All this, in the end, everything that you're creating is just taking up space in a particular location. And so when you assign a variable to it, you're just referencing a chunk of storage space. And so the question is, are we referencing the same chunk of storage space or two different chunks that happen to look the same? That's really what we're getting at here. And although this behavior can be useful, it is error prone, as you can probably imagine, right? If you don't know that two aliases refer to the same object, you might get yourself in trouble. It's safer to avoid aliasing when you're working with mutable objects. Now, for immutable objects like strings, aliasing is not as much of a problem. And in this example, it almost never makes a difference whether A and B refer to the same string or not. Why is that? Why do they say it's not a problem or not as much of a problem if the object is not mutable, if it's not changeable? Why? Why does it not make a difference whether A and B refer to the same string? little comprehension test for you here. I know this was a lot, so that's why I'm asking this question. It isn't going to break things as easily. Yes. Why? Why isn't it going to break things as easily? Exile says, because regardless of what variable you call, you will get what you expect. Why? Since the stuff inside is immutable, yes, that's correct. But why? Why? Yeah, why? Like I'm trying to get at, why is that true? Why? Exactly. Yes, that's what I was looking for. Exile. Thank you. Yes, they say because instead of accidentally mutating it and then calling it, that's not going to happen because strings are immutable. So the original original string that A and B are referencing is never going to change, right? If we change it, we need to create a new string entirely. Yeah, we're always going to be creating a new string. And so A and B, the string that they're referencing is never going to change. Strings are immutable, they can't change. But if we want to if we do want to modify this, if we want to, let's say, capitalize the B, we have to create a new string with the capital B. And so that's going to be a completely different object. And it's, A and B here are never going to have to worry about it. They're never going to reference that. They're always going to reference the old string, and the old string is never going to change. Yeah. And Blue Booger, welcome to the chat. They say you don't have to worry about A changing when you change B because you can't change B. Exactly. Yeah. Neither of these are ever going to change. If we want to, do something with this string, we're going to have to create a new string and store the modified version in that. Bananas need to be replaced. No worries, machine. Yeah, if we change one, we're going to create a new variable. No, your English is great, machine. You're fine. Yep. Exile says, but what about if I say A equals banana, B equals A equals not banana? Well, let's do it here. So A, let me just copy this. I think I know what's going to happen, but let's test this. All right, so A equals banana, B equals A, and I'm just going to quick print B here just to show what's in B. Banana. All right, and now A equals not banana. Banana. Okay, so we have A equals banana. B also equals banana because B equals A, and now A equals not banana. Now let's print B. What do we think we're going to see? Womp. Yeah, that's what I thought was going to happen. B still stays the same. B still stays the same. Now we print A. It's not banana. Because, as Percy said, not banana is a new object, so B remains banana. B still references the original banana string, which still exists because strings are immutable. B still references the original banana string, and when we reassign A, we're simply changing that association to a new string called not banana. Remember that when we do something like this, B does not reference A. B never does. B has no association with A. B is only associated with the original object. B is only associated with the original object. Both of these are references to the original object. So as soon as I reassign A simply gets assigned to a new object. B is not affected in any way. Yeah, when I reassign A to a different string, it's essentially, it's creating a brand new object somewhere else, and that's what A references now. Yep. Naomi Cedar, Percy says Naomi Cedar has a great talk on this. Oh, I'll have to check that out. I'll write down that name. Because yeah, this is something we've not necessarily had to think about before, but it is a pretty important concept, especially as we're thinking about immutable versus mutable objects. And if we change the original object, so if our object is mutable, then this is going to matter because both B and A refer to this object. And so if we change the underlying object, both B and A are going to change. But strings are immutable. So I can't change the original. Both B and A are going to reference the same object forever. I can cause B or A to reference a different string. That's fine. I can reassign it to a different string, but the original string is always going to be there. What's a practical application of this concept? Well, kind of like I just mentioned in, thinking about it in terms of SQL. Let's say that you have a variable that's auto-generated by the source system. So you're getting raw data from like a Raspberry Pi, let's say. I don't know. You're getting raw weather data from a Raspberry Pi. And, the current temperature is auto-declared in a variable. And it's but the variable name really sucks. It's not descriptive of the fact that this is actually the current temperature. And you're like, I want to make this easier. And so you say, all right, I'm going to declare a new variable called current_temperature, and I'm going to set it equal to the original temperature variable. Now, if that current temperature value changes, it's going to affect both the original variable and the new friendly variable that I've created. Those are my bananas. Thank you very much. Yeah. But yeah, there's a lot of, it's just something to think about as you're building your own applications. Be careful with aliasing if the underlying object can possibly change, because when it changes, you're going to affect every alias that's associated with it. However, with strings, not such a big deal because both of these are going to always reference the same original string forever unless you reassign them. XLTV, thank you so much for the follow. Pablo32T, thank you for the follow as well. Or just avoid mutations altogether. Yeah, it just depends on what you're trying to do, right? You should just be aware of what's happening and why, so that you don't make a mistake that's going to potentially lead to a lot of troubleshooting. Exile says, so do values and object distinction work differently for immutable objects? Objects, value, distinction. Not really. Not sure I fully understand your question, but do remember that the word value and the word object refer to two different things. So the value is what's contained in the object. So the value of this string object is banana, but the object itself is the entire string. It's the unique thing that is at that storage location. A is the reference. A is just a reference to this specific banana object. Banana is the value inside the object. So as we saw before, going back to this array example here, these are different objects, different array objects with different values. A and B are references to those objects. So the contents banana are the value. The object is this specific string entity that contains the value banana. A is not the object because A contains nothing. A is simply a way to reference this specific object that contains the value banana. Yes, I can say that's a good way to put it, Exile. So the object is the data type in the content at a specific location, and the value is just how it, what's in it. What are the contents? What does that object hold? Yeah. I mean, we don't have to get to, in the weeds. There's but just for now, just think about it in terms of a variable by itself is nothing but a label for a specific object. Yeah, as TV says. So data type, contents, and location, right? And the location part is important because these two arrays have the same data type and the same content, right? No, it's you had a great question. So let's think about it, Exile. These two both have the same data type and the same content, right? But yet, if we compare them, Python sees them as different objects because they're in different locations. They were declared separately. So in storage, they're in completely different places. Python does not see them as the same thing at all, even though to us puny humans, they do look like the same thing. But they were declared separately. Python wrote them to completely separate storage locations. They're going to have separate, memory IDs or whatever, memory addresses. I don't know. But instead, if I do this and I say A is this object, I've declared it once. Python writes it to a storage location. And then I say, hey, B equals A. Now B references that same object at the same place. And so Python's like, yep, those are the same thing. Now, if I do the comparison of B as A, that's true because they're both referencing the exact same object. You get it? Okay, awesome. Yeah. That's great. No, fantastic questions, by the way. It's good to go over this stuff once. We talk about it in one particular way, and then we talk about some specific examples, and then we go back over it a different way. And that's really crucial in more abstract or complicated topics like this. It's really vital that we keep sort of rehashing it and approaching it in slightly different directions until we can, get a better understanding of why this is happening or what these words mean, because they threw 10 vocabulary words at us in the space of 10 minutes, right? So we gotta rehash this stuff. Suraj, thank you so much for the follow. Good to have you here. Okay, now before we move on, I want to give this the time it deserves. Anybody have any other questions or want me to go over something again here? Because this is, I know this is wild, right? We're getting funky up in here. Okay, well, feel free to ask questions if you have them. Philosophy would deem this whole concept blasphemous. Yeah. Wild stuff. Okay, so when we pass a list to a function, the function gets a reference to the list. So what does this mean? When I call a function and I pass in a list, the function does not get the actual list. It gets a reference to the list. Gets a reference to the list. If the function modifies a list parameter, so if the function makes a change to the list, the caller sees the change. So here we have a function that removes the first element from a list. And what we're passing in is essentially like a variable, right? It's a special kind of variable called a parameter, but it is still a variable. And what does a variable do? By definition, what does a variable do? What does a variable do? Yeah, Suraj, it passes the reference, right? But all a variable does is associates a variable with an object. So that's why we say we're passing a reference. So when we pass a parameter and then an argument into a function, we're essentially passing a variable that refers back to the actual object. But what functions can do is then modify that object, and the caller then sees the changed object. So we're going to see an example of that. So delete head removes the first element from a list. So we have def delete head, we pass in a list T, and then we delete the first item from T. So T refers to a list. Whatever list we pass in, T is going to be assigned as a reference to that list. So then when we say del delete T and pass in index 0, it's going to delete the first item of that list, whatever it is. So when we say, all right, letters equals A, B, and C, so it's a list containing A, B, and C, we call delete head against letters. So we're passing in a reference to our list object, A, B, C. And when we run the function against our list and we perform some kind of action against that list, the underlying object has been changed. Because T and A both, T and L, T and letters, both refer to the same object, and T0 refers to A. So what do we call it when two different variables refer to the same object? What is that called? What's the term for that? It's the title of the previous section, hint, hint. Yeah. It's an alias, right? Yeah. We essentially are auto-assigning this variable T to this whatever object we pass in. In this case, it's this one right here. So both T and letters refer to this object. That's why when we pass in letters, we can perform this operation, even though we're passing in the word letters, we can perform this operation against whatever we pass in, because when we do that, T becomes assigned to ABC. We perform the operation, and if we call letters again, if we print letters now, the underlying object has been changed. So the parameter T and the variable letters are aliases for the same object, which is this one right here. So it's important to distinguish between operations that modify lists and operations that create new lists. The append method modifies a list, but the plus operator creates a new list. So let's see an example of that. We define T1 as a list containing 1 and 2. Now, if we call the append method on T1 and append the value of 3, then we print T1, we'll find that the original list has been modified, right? Because lists are mutable. And so when we call a method on a list, it's going to modify the list that we're calling it on. That's just how lists work. However, methods don't return anything, right? They just modify the list and then they're done. They don't return anything. So if we try to assign that value to T2 and try to print it, we get nothing back. However, if we say T3 equals T1 plus an individual list containing the value 3, now we get something back, because the plus operator creates a brand new list containing those 3 values. And then if we try to check and say T1 is T3, that's false, because it's created a new object called T3. Well, T3 is a reference to the new object that we've created. This difference is important when you write functions that are supposed to modify lists. For example, this function does not delete the head of a list. The slice operator creates a new list and the assignment makes T refer to it, but none of that has any effect on the list that was passed as an argument. So let's go over that again. The function here is saying, all right, we're going to pass in a list called T, And then the function body says t equals t, essentially starting at slice 1 and going to the end of the list. Now, what this is actually doing here is it's creating a new list and reassigning t to that new list. However, the original list hasn't been changed at all. Instead, what you could do, instead of reassigning it, is just create a function that returns the modified version of the original list. So, how do we use it? Letters equals ABC. Oh, Exile says, what if you did T1 is T2 after the first section? So this one here. This, I'm assuming you're asking about this one. Let's do it really quickly. All right, so T1 is a list, 1 and 2. We take T1 and we append 3, and we set T2 equal to that. All right, and then we already know that if we print T1, we'll see the list with a 3 at the end, right? And if we print T2, we see a value of none. So what do we think? I'm going to ask you, chat. What's going to happen if I say T1 is T2? Will it be true or false? Hey, and it's a coin flip. So if you're completely lost and you have no idea what's going on, you can still guess and you might be right. What's going to happen if I say T1 is T2? Do that and say, are they the same object? Are T1 and T2 references to the same object? True or false? What do we think? Siraj says false. Exile says false. Why is that? Why do we think it'll be false? Let's test. T1 is T2. False. Yeah, why? What did we say that methods do? They modify the original object, right? They modify the original object, correct? It's a list, and so the method is going to modify it. But what do these methods not do? What did I say earlier that these methods don't do when you call them? They modify the underlying object, but they don't what? They don't what? They don't return anything. Exactly. Yeah. So we can't assign T2 to this because the method doesn't return anything. There's nothing to assign it to. This is literally just a function that is modifying the underlying list, and it doesn't spit out squat. There's nothing to assign it to. And so that's why T2 is none. Because it's just an empty reference. It doesn't belong to anything. Yeah. Good question. Yep. Yeah, and it may work differently from Java. I don't know. I'm not familiar enough with Java to tell you. But yeah, hey, Dan. Dan's excited because Dan has been itching for us to get to lists and dictionaries for ever since this series started. So congratulations, Dan. We are talking about lists today, and we're going to be talking about different dictionaries next week. Yes, exactly, Dan. Dan's very excited. Okay, let's see where we're at. All right, so here in this case, we have a list of letters, and then we have our tail function here that passes in letters and prints the rest. And what it's doing here is it's returning the value of T starting at index 1 and going to the end. So essentially printing everything but the first element of that list. And in this case, we can reassign it to a variable because our function does return a value. We are explicitly returning a value here. So that's the difference. If you want that to work properly, kind of what you were talking about, Exile, if you want that to work properly, if you want to do a function on a list, and instead of modifying the original, you want to just go ahead and assign it in a new value, you can do that by explicitly returning the result. That's going to return something, which means there's something to assign it to. There's something to assign our rest variable to. And now when we print it, ta-da, we get a result. LLMs win. Ha. Now I have great admiration for the people who build those, but I'm not one of those people. Okay. Whew. Congratulations, everybody. We just covered a lot, right? That was a lot to think about, a lot to digest. But fortunately, we're done with this section. So you can massage your brain a little bit. Yeah, we lost like 10 viewers throughout that. People were just like, no, I'm out. So if you stuck around, congratulations, you got through it. That was probably the toughest thing we've talked about so far. But good job, everybody. So real quick, we got to talk about debugging. Because when you're working with something like this, when you got immutable objects and mutable objects and references and aliases, there's a lot of things that could go wrong, understandably, right? So careless use of lists and other mutable objects can lead to long hours of debugging, as you might imagine. Here are some, we're going to do an exercise in just a minute, Suraj, don't worry. Here are some common pitfalls and the ways to avoid them. Don't forget that most list methods modify the argument and return none. That's what we just talked about, right? A method can modify an argument. It'll modify the original object, but it's going to return none. This is the opposite of string methods, which return a new string and leave the original alone. Again, that's because strings are what? Strings are what, chat? Immutable, exactly. Yes. So string methods have to return something because the original is immutable. We can't modify the original, right? So list methods modify the argument and don't return anything because they are modifying the original, because lists are mutable. String methods are going to return a new string because they can't modify the original, because strings are immutable. All right. So, Royalty, thank you so much for the follow. Good to have you here. If you're used to writing string code like this, where word equals word.strip, because doing this is going to strip the white space from the original string and create a new object and assign this reference to that object, that new object, this string method is going to return something that can be assigned here. However, we can't do the same thing for lists because list methods don't return anything. Let's see. Dumb question. No, there's no such thing as a dumb question. So why in Python does one need to do like t1.appendx rather than just saying t1.appendx? Is there any point to the t2 part of the code? So let's real quick recap here. So we'll say t1 equals 1, 2, 3. T2 equals t1.append 3. Yeah, I'm just doing a quick I'm just doing a quick illustration as to why Exile is asking that question. So t1.append 3, and then we will print t1. So we can see that the original has been modified, right? Because it's a list method. And then print T2, none. Exactly. So what Exile said, why do we have to do that? And the answer is you don't. So as Suraj said, that was just for an explanation. You don't have to write that. You can just do, T1.append whatever. You don't have to set it to anything because it's not going to do anything anyway. So the assignment part, I think, oh, hey, Balsafik, good to see you. The assignment part at some point here, I assume you're referring to this. That was literally just to do this print right here and to show that it returns nothing. Yeah. Yeah, that is literally just done to show that it doesn't return anything and it's not something that you have to do. Yep. All right. So, you don't do that. And because because nothing is returned from a list method, the next operation you perform with T is likely to fail because T is now, none. Before using list methods and operators, you should read the documentation carefully and then test them. That's probably the best way. The methods and the operators that lists share with other sequences like strings are documented here. So you can, bookmark that. And then mutable sequences are here. And then pick an idiom and stick with it. I like this. Part of the problem with lists is that there's too many ways to do things. There's too many darn ways to work with lists. And it's kind of the similar problem in JavaScript, right? If you've ever done a marathon of practicing array methods and array problems in Code Wars or something, there's like 5 or 6 ways to potentially slice and dice an array, mess around with it, that kind of thing. So to remove an element from a list, you could use pop, remove, del. There's just so many different ways to attack it. Or you could even do a slice, right? To remove an element. And to add an element, you could use append or plus. But in the end, you should just pick one and stick with it. And you should understand what each of them do and, try to pick the best option for what you're trying to do. In this case, as Exile just asked, what are the right ways to use a list method like append? Well, you just use it. It doesn't return anything, so you can just kind of declare it. But if you're doing a, plus operator, doing concatenation, then you do need to store it because you're creating a new list object. Thank you, Shazera. Thank you for the follow. Good to have you here. You should not do any of these things. I'm not going to read them out. You can just, look at those. I don't want to confuse people, but these are all wrong. Don't do these. It's going to take some trial and error. It's going to take some practice to remember how to do each of them. I actually, like I mentioned earlier, I actually fell into the none trap when I was trying to do a sort on a list. I was trying to do a sort on a list earlier, and I tried to just print it. I was like, I want to do the sort and the print in the same step. And it just kept printing none. And I was like, what is going on here? And yeah, that's why I hit the trap. Now, make copies if you need to keep the original list. So in this case, we can say original equals just the whole list. And then I'm going to modify the original by calling sort. So we can make a copy and then call sort and modify the original. In this example, you could also use the built-in function sorted, which returns a new sorted list and leaves the original alone. But in that case, you should avoid using sorted as a variable name. So yeah, there's another function we could use here, which leaves the variable, the original alone and returns a new list. But you'd have to just be careful with your variable names. KO says, team append. Exile says, down with concatenation. I love the word concatenation. It's great. Hey, Matthias, good to see you. All right, let's talk about lists, split, and files. So how do we work with data in files? As we've talked about before, you're going to be working, if you're working with data of any size, you're inevitably going to be working with some garbage, right? You're going to be working with some stuff that doesn't make sense, stuff that you never could have tested for. If you give users the opportunity to generate text, they will generate the weirdest stuff you've ever seen, and you're not going to be able to parse it. So it's a good idea to revisit a guardian pattern when it comes to writing programs that read through a file and look for a needle in the haystack. So if we're looking at the day of the week from our file, like we did before, we're breaking this line into words, and we can dispense with the use of starts with and simply look at the first word of the line to determine if we're interested in the line at all. We can use continue to skip lines that don't have from as the first word. So we can say, hey, if the first word is not from, then continue, go to the next loop. Yeah, Exile says, marking first year college papers is a perfect example, right? Yeah, exactly. And, and I see that all the time as a data engineer with the data that we get. We have to often process student quizzes. We don't grade them, but we ingest the data. I work for a major university, which is the context for this. I work for a major university with a data warehouse. So we are taking in hundreds and hundreds of quiz answers, test responses, that type of thing, and ingesting those into our database. And you get some wild stuff. You get HTML tags, you get Unicode, you get emojis. We get emojis a lot. I don't know why, when I was a student back in my day, we would never answer a quiz question with a smiley face, but the kids today do that all the time. So you have to be able to process that kind of thing. Or, foreign characters in names, stuff from every single language you can imagine, entered as text. Yeah. Yeah, it is kind of fun in a way to figure out how to tackle it, but you just got to make sure that you're doing things like, how are we how are we accounting for those inevitabilities and protecting our scripts and our programs? So in this case, what we're doing is we're saying, if the first word is not from, then continue. So what do we see? What I'm going to scroll up here. What could potentially go wrong with this? We're just saying, we've simplified our program to say, if the first word is not from, then continue, and then we print the word at index 2. So what could go wrong here? What's a potential pitfall of doing this? If the word at index 0 is not from, then continue. If the first word is from, then print the word at index 2. What might happen here to cause an error? What could cause our program to fail? Where's index 1? Potentially, yeah. We're not specifically referencing index 1 here, but what you're close. You're close. We're looking at index 0 and we're checking to see whether it's equal to the word from. If it is equal to the word from, then we want to print the word at index 2. What could go wrong? Yeah, what happens if there is no word other than from on the line? The first word is from, and then that's the only thing on the line. And we don't really care why that would happen. You might say, well, why would they do that? All sorts of stuff can happen. Formatting is hard, right? You might be let's say you're parsing a letter. They might put the word from on one line and then do a return, and Python's going to see that as a new line. So what if the only word on the line is from? We say, all right, the word at index 0 is from, and then the next line is going to say, okay, I'm going to print the word at index 2. There is no word at index 2. Oh no, our program doesn't know how to handle it and it fails. So what went wrong? Well, in this case, so, there's multiple things that could go wrong. But the first thing you can do when troubleshooting is try to print. So you might not be able to look at the file directly, But what you can do is, add console logs, right? When we're working with JavaScript, we end up adding a lot of console logs. The best place to add the print statement is right before the line where the program failed and print out the data that seems to be causing the failure. So we add a print of the variable words right before line 5. So we can see here, we're splitting it up into lines and then we immediately print the entire line. We can even add a prefix debug to the line so we can keep our regular output separate from our debug output. So in this case, there are no lines. There are no words on the line. It's an empty line. The first line is this. The second line is this. The third line is empty, and that's when it fails. But you might say, okay, fine. Why did the program get through this then? Why did it fail here? Well, technically, an empty line. Well, I guess, yeah, in this case, it would fail here, right? It would fail here. It would go to the next loop. But there's nothing at index 0, so it would fail. Yeah, so this would fail here. But the second place it would fail is if the word from was the only thing on the line. So there's multiple points of failure. Awesome, cool. So not only do we need to check, so the first thing we should do is just check to see whether there's anything on the line at all, right? Is it a blank line? Blank lines are super common. The first thing we need to do is check to see, all right, is it a blank line? And if it is, we just skip it. And we also need to make sure that there's a word at index 0 and at index 2. So multiple points where everything could go very badly. Of course, there are 0 words on a blank line. When the code looks for the first word to check and see if that matches from, we get an index out of range area. So we need guardian code, right? We need checks. Exile says, put it in a try statement, save the world. Sure. Yep. You could do that. Or since we're doing a loop, you could just have a specific check and then say continue, which will cause it to go to the next, iteration of the loop, right? It'll stop the loop where it is. Yeah. Exile says, if list is empty, then get out of there. Yeah. So in this case, what we're doing is saying, all right, if length of the line, all the words in the line, if the length of that list is equal to 0, so that means that there's no words in the line, then we go to the next loop. Also, if the first word is not from, then we also go to the next loop. And then you could even put a third check in there to say, if words 2 is I guess if the length of, you'd probably say if length of words is less than, if length of words is less than 3, right? If length of words is less than 3, then we would just want to go to the next loop because it's not going to give us what we're looking for. So you can comment out your print statements, check and see if we have 0 words in the line, use continue to skip to the next line. And we can think of the 2 continue statements as helping us refine the set of lines that are interesting to us and which we want to process some more. A line which has no words is not interesting to us, so we skip to the next line. A line which does not have from as its first words is not interesting to us, so we skip it. Our guardian statement does make sure that word 0 will never fail, but perhaps it is not enough, like we were just talking about. When we're programming, we must always be thinking what might go wrong, especially when users are involved. The capacity for human error, the capacity for humans to make errors is infinite. It's like the monkeys and typewriters thing, right? Everybody has the capacity to generate, to make infinite mistakes, and that's just a part of being human. And that's how we end up making really cool stuff like Post-it notes. Post-it notes were a mistake. But we also have to control for that in our code because our code has no tolerance for mistakes by default. We need to give it tolerance for mistakes. Yeah, generate them too nowadays, yeah. Programmers are foresight specialists. Yeah, well, that's why it's important to be, as a programmer, to also be a good communicator. and to be able to talk to people and to be able to understand how people think and how they work. That's going to help you generate better programs because you're going to be able to account for the things that people do and how they, how they interact with your script. Yeah. Hey, Five Shot, good to see you. Matthias says good programmers are so tolerant. Yeah, or they, or they are really good at sanitizing inputs. Yeah, computers are not smart on their own. Correct. Yes. Computers are not smart on their own, and they have to be given every possible scenario and how to handle it. That's just, until we get some kind of, artificial general intelligence, right? And even then, it's not going to be smart on its own. It's going to be shaped by humans. All right, so now it's time to do an exercise. We're going to plow through these couple exercises here. So let's see, lists, here we go. Of course, Silly, thank you for being here. Good to have you. Exercise time, let's go. All right, we're going to open a file called romeo.txt, and we're going to read it line by line. For each line, and I see your question, Five Shot. If you can stick around, I want to do these exercises first, and then I can talk about that. They asked what a SQL developer is for a major university. Yep, I will talk about that, but we're going to do these exercises first, and then I'll circle back to that. All right, so we're going to open a file called romeo.txt, and we're going to read it line by line. For each line, we're going to split the line into a list of words using the split method. The program should build a list of words. For each word on each line, we want to check and see if the word is already in the list, and if it's not, we're going to append it to the list. So essentially what we want to end up with is a list of unique words in this text. So no repeats. When the program completes, we want to also sort and print the resulting words in Python sort order as shown in the desired output. Okay. So they've given us some starter code here. So what I would like to do is we're going to copy this over to VS Code and we're going to do it there. It's a little bit easier to work with. So I'm going to drag this over. So you can see that what we want to get to over here. And we're just creating a new file. I've already downloaded the original text file and I'll show you what that looks like. So it's just a sonnet from Romeo and Juliet. So pretty short. So we'll say RomeoParse.py. So we're going to take that and we're going to drop in here the starter code that they gave us. So we're just going to see what this gives us for starters. All right, and I need to fix my indentations here. So for each line, we're taking in a file name, which is the file I already have saved here. We're going to open it. We're going to create an empty list. And for each line in this file, we're going to print the line and remove the white space. And I know I asked this question earlier, but removing the white space, as a reminder, essentially removes the carriage return at the end of each line in a text file because the print function adds one back. So I want to show you what that, first I'm going to show you what that looks like if we didn't do that, if we didn't strip from the end here. Romeo parse.py. Oh, let's see. Did I spell that wrong? Oh, I'm still in the interpreter. That's why. Hang on. I got to quit it. Okay, there we go. Py, Romeo parse.py. Okay, enter file name. File name is just romeo.txt. Okay, so now notice that it's just going to print out each line, but look at the extra, see the extra carriage return there. So because we didn't strip the original carriage return off, the print function is going to add an extra one, and so we end up with 2. So if I add the rstrip back and save it, we'll run this again. Now it's going to be single spaced. So that's why we do the rstrip there. All right. So what do we need to do here? We need to get a A list, which is they've given us here, LST is going to be our list. It's an empty list, and we need to put each unique word in it. So I'm going to loop through each line, and instead of printing it, what's the first thing I want to do? You don't have to give me the exact syntax, the Python code, just thinking about it. Thinking about this conceptually in a pseudocode type of a way, what's the first thing that I need to do to each line as I'm looping through it? My goal here is to get an array of words. So what's the first thing I should do to this line? Yeah, we're probably going to want to turn it into an array of words, right? Or a list of words. We're going to take that line, we're going to split it apart. Yeah, we're going to want to split the list on space. Exactly. Yep. Hey, Redell, welcome to the stream. I like that. Thanks, Red. A Python program walks into a bar, it forgets to close the parenthesis, and the bartender throws a syntax error. This joke is missing a closing parenthesis. Syntax error. Unexpected end of file while parsing. I like that. It's great. Yeah, we're going to use the space as a separator, exactly. And we're probably going to want to, we're probably going to want to strip it as well. I shouldn't have gotten rid of that. So we're going to say, we can strip our line, get rid of that, get rid of the any white spaces, and then we're also going to split it out into a list. Exactly. Yep. So we can say words. We'll say words equals line dot split. And then for now, let's just do that. We'll just print words. Let's see what that looks like. Print words. Okay. And save. And Romeo.txt. There we go. Nice. So now we have each of those lines split out into a list of words. Perfect. That's exactly what we're going for. So words equals line.split. Now, what's the next thing I need to do? I have my lists of words, and my goal here is to add words to the list if they don't already exist in our list. So what's my next objective here? I essentially want to check and see if each word is unique. And if it is unique, I want to add it to our list. Exile says, now you need a for loop to check each word against each other one and create a new list with only unique words. Yeah, that's one way we could do it. Or we could simply check each word against the existing list, right? We don't even need to do something like length word. We can just say, because you might have two words of the same length, right? The and are the same length, but they're different words. Yeah, exactly. Yeah. These are the types of questions we got to think about, right? But all we really have to do is say, if a word already exists in our, in our list here, our unique list, then we discard it. Otherwise, we add it to the list. So we can say something like for word in words. So for each of the word in each line, right? For word in words, we can then say if word Exile says, so if list X is in the list, then keep it, else get rid of it. Yeah, essentially. Yeah. Actually, yeah, you're right. We should say if not word. Exactly. If not word in list, then we want to add it to the list. Yeah, that's the way to do it. So if not word in list, then we want to add it to our list. So we want to say, we could just say, well, it's going to be, sorry, LST, my bad. LST. So, because that's our empty list, right? So if the word is not in LST, then we want to say LST, nice, there we go, LST dot append, you could probably just append it, right? Append word. And then if it is in the list, then this if statement gets skipped, and then we go to the next loop. So is that going to work? Let's see. Input, open, list, here's our empty list. For each line, we remove the white space, and then we split it out into an array of words. And then for each word in words, so each word in our words list, if the word we're currently looking at is not currently in our master list here, the one we're trying to print out, if it's not in there, then we add it. Okay? Seems fine. We'll see if it works. All right. So once the loop is over, so once we've done that, right, we should have a populated list. What's the next thing we need to do? We want to, when the program completes, we want to sort and print the resulting words in Python sort order as shown in the desired output. So what if I do, will that work? Will this work, chat? Can I do this? Will it? Let's try it. I'm not so sure. Okay. Let's not short. Let's see. We're about to see. Yeah, we're about to see. That's what I'm guessing we're going to see, Buet. But we'll find out. I have a pretty good sense that that's what we're going to see. All right. File name is Romeo. TXT. Yeah. That's what I thought was going to happen. Why? It's all the stuff we just finished talking about, chat. What did we say? This is a list, right? LST is a list. What happens when I call a method on a list? What happens when I call a method on a list? What does it do? It mutates the original object, right? And it doesn't return anything. It mutates the original object. So it is doing the sort here, but it doesn't return anything. Exactly. So there's nothing to print. Right. As Gaia said, first we need to do the sort and then we need to do the print. Exactly. Yep. We need to print the object itself, not the method call on the object. 100%. So I kind of knew this is what we were going to get, which is why I did it, because I wanted to have this discussion again. So Cellophane says, so you sorted it, but where is it? It's still exactly where it always was. We haven't gotten rid of anything here. But what's important to remember is that when you're calling something like print, when you're calling something like print, you're calling a function. You're calling a function. And when you call a function, you aren't passing in the object itself. You're passing in a reference to the object. And sort itself is a method that doesn't return anything. And thank you for the posture check. So this right here, this is nothing. This is a reference. It's a reference to a function, and that function doesn't return anything, so there's nothing to print. So you're passing in an abstraction here. Oh, thank you for the hydrate. Yeah, wild, right? So you don't have to think about it too hard. Just remember that if you're calling a method on a mutable object, on a changeable object, it doesn't return anything. And so we have to do this. We're going to mutate it first, and then we're going to reference the object directly and print it. Save. All right, let's try this. Yeah, no, we're getting funky here, right? This is tough. That's why I keep coming back to it, because we got to keep talking about it. There we go. Check it. It should be named sorted if we want to. Well, there is a sorted method, and that's different. So there is one, but that's different. So they're two different methods. And sorted actually does return a new version of the object and can be reassigned. But we're using sort here, and so that one doesn't. But hey, I think this looks right, folks. It's given us a nicely sorted list of some unique words. I've checked the first one and the last one, and they look the same, so I think I'm happy. All right, let's drop this sucker in. Let's see how we did. Buit says, is that line.rstrip having any effect? It is. And we actually tested that earlier. I'm not sure if you were here or not. But the first thing I did when I copied this, so they gave us some starter code here. The first thing I did when I copied it over is I got rid of the rstrip and I printed that. And then I replaced the rstrip and I printed it again. Chat, what was the difference between those two? What was the rstrip doing? I'll even scroll up so y'all can remind yourselves. Yeah, it's removing empty space. Yeah, it's removing trailing white space. Yep. So it removes trailing white space, and then the oh, Timinator, thank you so much for the follow. Good to have you here. Oh, you're good, Matthias. No worries. Okay. Oh, sorry, Buit. I missed your I missed your the point of your question. Okay, yeah, I get it. So in this case, I think you might be right. So I think what we should do is, well, here, let's try it both ways. Let's do this. Do a quick little test here. First off, I'm going to take the finished version here. I'm just going to drop it in so we don't lose it. And then I'm going to take this. Timinator, I like your username. Hey, Code. Hello. How you doing? All right, we can kind of mess around with this one. This is just the starter code. It's a little simpler. All right, so we're going to say for line, I'm just going to say print line, and then we're going to take this and we're going to just do line.rstrip. Yeah. Oh, and then I want to say for line here, line.rstrip. Yeah, that's what I want to do. All right, and then we're going to do this. And what I'm checking here is to see if this rstrip is doing anything, because as Buit pointed out, strings are immutable, right? Strings are immutable. So I'm not modifying the original line, and I'm not reassigning it. So I don't think we're doing anything. So we're going to try it. Yeah, it's not doing anything. So you're exactly right, Buit. That's a great catch. All right, so let's do this. I'm going to put the original back here. Because as Buit rightly pointed out, if I'm calling just line.rstrip, this is a string. We haven't converted it into an array yet, or a list yet. So this is still a straight up string. Now, in the context of what we're actually doing here, it doesn't really matter because we're only looking at unique words. So it's not, it's not a huge deal. But yeah, this is not doing anything. So what we could do instead is we could say something like str underscore line equals line.strip, and then we're going to take that. So we're essentially stripping the line. We can't modify the original string, but we can assign it into a new variable, and then we're going to take that and split it out into the list. Save that. We'll try it again. It's not really going to change the output in this case, but it is a good catch, and we should fix it. Yeah, so still fine. And I'll catch up with chat in just a second. I apologize. I just wanted to kind of power through this. All right, so check code. Enter file name, Romeo txt. Hooray! We did it. Lo hicimos. We did it. Yeah. All right, done. Cool. Let's do the next one. Okay, and I'm going to catch up with chat first. Sorry. Garrick says, why don't we just use tuple? Literally just came to stream, so no clue. No, we haven't. We actually haven't covered those yet. So we have a lot more data structures to cover, and I'm sure we'll get to that in just a bit. But yeah, just something we haven't covered yet. Yeah, we'll get there, I'm sure. I bet we'll get there next week, honestly. Because next week we're covering even more data structures. Hooray! Let's see. Pace Dodo says, what website is this? This is Python for Everyone. Or sorry, yeah, Python for Everybody. My apologies. And it's a wonderful free course created by a professor at the University of Michigan. It's 100% free, and it's fantastic. I love it so far. It's entertaining. It's very application focused, so you can apply what you've learned to real world situations. And it's been a really great course so far. I would highly recommend it. You can get the link by doing !project in chat. !project. That will give you the link. Looks like my bot actually posted it for you there. Yeah. 5-star. I saw you mentioned file closing earlier. Yeah, I think it was touched on. But we haven't really, dwelled on it too much. But yeah, I know that if you want to be really safe and make sure that the file was explicitly closed, you can call file.close just to make sure that it's released from memory. Now, I mean, closing files is really important. You don't want a particular program, holding on to a file and preventing it from being modified elsewhere if you're actually done with it, right? And that's actually something that I encounter at work sometimes. And anytime you've got a LAN drive with a bunch of shared files on it, we still use like the old school versions of Word and Excel and stuff, like the non-cloud versions. And so they do not handle shared files very well. So, if somebody else is editing the file, and I've done this millions of times, I'm the type that, everybody gets annoyed with because I will open an Excel file and then, I get distracted. I have ADHD. I own that. Like diagnosed ADHD. And so I will open up a file and look at it for 10 seconds and then get distracted by something else or go to lunch or whatever, leave the file open. Somebody else needs to modify it. And, frickety frack, the file is still open. Nobody can touch it. So yeah, it's important to do. Definitely. All right. Sorry. I'm just scrolling back through chat here. I think I missed some stuff. Somebody's honking their horn outside. You gotta honk your horn. This is a suburb. Come on. Okay, yeah, I think we're good. Close them files. Yeah, if you're working with a very large, very large files, you could actually be, consuming memory if they're stuck open, right? Yeah. All right, let's look at our next exercise here, and then we're going to wrap it up. Yes, you could also use the with keyword, right? So it's only going to hold that file in memory as long as you're working with it. I imagine we'll probably get to that at some point. I think we maybe touched on it in the file lesson. I don't remember. But yeah, you could use the with keyword. That's actually something that also exists in SQL. The with keyword is universal between the two. So yeah, you can say with the file as whatever, and that's actually the same syntax as SQL, which I find very interesting. And it does a similar thing. You can use a with statement in both Python and SQL to essentially create a temporary object. So that object only exists as long as you are working on it. And once you are done working on it, it will disappear, vanish, free up resources. Yeah. So in SQL, that's called a CTE, Common Table Expression. I don't know if it has a special name in Python, but that's a thing in SQL. So the more you know. Server horror. Hey, welcome to the stream. Man, I dig that server. I love Microsoft Excel. I've stated that many times. I am a huge Excel fan person. Legit think it's the best piece of software ever created. And so I love any random like office facts. I think that's awesome. They say, I'm not proud of it, but I know that Word can actually do master and sub documents, at least since Microsoft Word 97. That helps. That's rad. That's so cool. I dig it. Yeah, and yeah, we can do that. We've done that with a few things, but it's just not something that people think to do, at least on our team. And so then, we all have to message each other and be like, close the file, you know. 30 gigabyte CSV files need to never be opened. Exactly. Yeah, and that's actually something that the course does cover. They say, you need to be careful with what you're doing with a file depending on how big it is, right? You don't want to go through and read an entire file that's 30 gigabytes, right? You only want to do what you need to do with it. Celeste says, I love frickety frack. Reminds me of something off of Battlestar Galactica. Yeah, when you're not allowed to curse as a kid, you come up with some unique ways around it. Percy says, I read somewhere that Microsoft Excel supports Python now. It does. And you know what else it supports? TypeScript. You can write native TypeScript functions directly in Microsoft Excel to do stuff. And that's freaking awesome. Yeah, it's so cool. I've done a little bit. I haven't, because I'm old school as far as like, um, writing things in VB script or whatever, old school macro coding. But I have dabbled around with the TypeScript a little bit, and it makes things so much easier. Yeah, you can do Python and you can do TypeScript iced. So whatever, depending on what you're trying to do, you can use the language that works best for you in Excel, and it just works. It's rad. It's so cool. And it like opens up in a little like editor on the side. It's so much easier than doing VB macros. I banged my head against many a macro code years ago. I know. Percy says, how will VB engineers gatekeep Excel now? I know, right? I used to think I was so special and had this magic power to build macros. Now, just anybody can do it. All right, let's do this exercise. Okay, so we're going to open another file, mboxshort.txt, and read it line by line. And we're looking for a specific line. And if you were following along through the rest of the lesson, this might look familiar. We have a line that contains an email address, starts with from, contains an email address, contains a day, contains a month, a date, a time, and a year. And we're going to parse the from line using split and print out the second word in the line. So we want to find the entire email address of the person who sent the message. Then we're going to print out a count at the end. Okay. So we want to make sure not to include lines that start with from and have a colon. And look at the last line of the sample output to see how to print the count. So what they want is essentially this. They want just a whole list of all these email addresses. And then they want to say the count, right? There were 27 lines in the file with from as the first word. And fortunately, they've given us some sample code here. So we're going to do the same thing. We're going to print it. We're going to put it in a new file here. And we're just going to say, I don't know, email parse.py. And I've already downloaded the file that they want us to read from. So I've got that here in my file list. I'm going to copy the starter code and we're going to see what that's doing. Drag this over a little bit more. Here we go. Hide that there. Yeah, you should be able to see it now. Okay. It's asking for a file name. Now, what is it doing here? What is it doing here, chat? It's a little bit of an extra check, right? We didn't have this in the other one. It just said input file name and open it. What are we doing here? No worries, Exile. Thank you for being here. It's great to have you. Good questions. Thank you for that. Soon I'll just be telling Excel, run a regression, and it'll do it. I mean, Microsoft is going to shove Copilot in there, and, I think they already have, and I'm sure it'll be able to do stuff like that. So, chat, what is happening on lines 2 and 3? What is this doing? Hey, Null Recall, welcome back. They say it's defaulting to open the mbox file. Yeah. So essentially, if the user doesn't enter a file name, then we're going to default to this file. So exactly, Icefire. If the length of whatever the user enters is less than 1, meaning nothing, if they didn't enter anything, then open this. What would happen if we didn't have this? Well, I guess what would happen in this case? What could go wrong here in the previous exercise that we did? What could go wrong here? How could a user screw this up? Always something important to think about when you're developing code, right? How could a user screw this up? Yeah, exactly. No file name given, wrong file name given, right? There's a bunch of different ways. And this isn't perfect, right? It's only checking length. It's not actually checking to see if the file name exists. So they could just enter random garbage and it would fail, right? But at least it's checking to see if they entered something. Exile says, why use a length method instead of just checking whether they input a file name or not? But how would we do that, Exile? Nil says, yeah, by not entering file name. Yep. Griffway, welcome to the stream. Hello. Good to have you here. Oh, and J6TV, I'm so sorry. I forgot to thank you for the follow. Also, Huna, thank you so much for the follow as well. Thank you both for being here. Sorry, sometimes I miss those alerts. My bad. Yeah, we could do something like an isEmpty function. I'm sure that the reason that they did it this way in the sample code was just to remind us of this method. There could be a better method to do it. I'm imagining that there is probably something like isEmpty. I would have to Google it, Python methods and see. But in this case, I'm sure they're probably just using this to remind us that it exists, not just for lists, but also for strings. It's part of that kind of that active recall of like, hey, this also works for strings. But yeah, so we're doing this check first, and then it's opening it, and it's initializing a count variable. And then for each line in the file that we've just opened, we're going to split it. Kind of like what we just did for the other one. There's a little bit of deja vu here. We're going to split it out into a list of words, each file. If the first word is from, then we want to print the second word and increment our count. All right, let's run it and see what happens. So we're just going to see what they've given us to start with, and then we'll see what we need to do to modify it. Okay, let's see this. Yep. All right, email parse. Oh, actually, you know what? I did try one of these earlier. I think this is my code. Whoops. I should have clicked reset. Well, you get to see the answer. Because, yeah, I wanted to try one of the exercises to see how hard they were going to be. I think this is the one I did. All right, we'll see. You said it. Yeah. So forget this stuff. That's what I did earlier. I didn't submit it though, so I don't know if it's right. So I could even be wrong. You'll see that it's not been graded. So I did take a crack at it earlier, and I ran it in VS Code just to see how hard it was going to be, but I didn't check it, so I might be wrong. This is the default code that they do give us some default code though. So we'll grab this, put this in. All right, this is the default. Save that. Let's see what they've given. So here they're doing the check still. We open the file, count is initialized to 0. All right. So, I mean, I think there's really nothing to print here. That's fairly straightforward. So essentially we can kind of, like I said, we can kind of reuse some of what we did here, I think, for the line in our file. Let's see. We're not going to need to do the strip on this one, I think, because we're never going to hit the end of the line. So for line in FH, we just want to split it. So grab that. We'll just say line.split. Oops. Line.split. And then now we have our splits. Oh, thank you so much, Mokes. Thank you for being here. Good to have you here. So now we have the line broken out into a list. And then, let's see, what was the next thing? We need to get the first word, if. So if words line dot split. All right, so sorry, for word in. Well, actually, no, we don't even need to do that. We can just say if words 0. Oops. If words 0 equals from, not from with a colon, just straight from, sorry, equals from, my bad. Equals from. Hey, good to have you here, Mokes. If words equals from, then we want to go ahead and print, oops, not a semicolon, full colon, thank you. Then we want to go ahead and print words at 1, let's see, 0, 1. Words 1, not 2, 1. Otherwise, we want to skip it and we want to go to the next line. So that's pretty much it. Now, just like before, just like kind of we just finished looking at in the reading, what's something that could potentially go wrong here? Before we even run it, what's something that could potentially go wrong? I haven't, I'm not looking at the original file right now, but what's something that could go wrong with this, depending on the contents of our file? Oh, yes, and we can, Garrick, yes, we could potentially chain methods as well, yes. In this case, I don't think it really matters because we're only looking at the, the second word. Yeah, Percy, yeah. What if the line is empty? It's going to fail right here. Not to mention fail here, but it's going to fail here first. Yeah. So what can we do? Well, we could do something like this, right? If length words is greater than 1, maybe. And wait, what's the or greater than 0, sorry. Greater than 0? Yeah. Yeah, we can do a try catch. What's the short circuit command? And it's and? Okay. All right. Yeah, I was thinking I got sidetracked in JavaScript there. I tried to do a short circuit with the JavaScript syntax. Too many languages. Yeah. All right. Words greater than 1 and words from, print words. Okay, perfect. Let's try that. I'm going to say email. Oh, I got to save it first, though. Email parse.py. Oh, sorry. Py email parse.py. Okay, file name is, well, I can just leave it empty because it's going to check for that. Hey, check it out. All right, great. So we're almost there, but we're missing the count. However, it looks like the email addresses look to be correct. Yeah, lots of languages in your head. Exactly. From Willow, welcome to the stream. Good to have you here. Thank you for the follow. So now the next thing we need to do is just finalize the count. And so for that, we can just add 1 to the count. In order to do that, we can do it a couple ways. We can say count equals count plus 1 and just reassign it. Or, chat, what is the shorthand? What could we do instead? Make it a little bit slicker. Bring some Code Wars swag. Yep. Why don't we just do count plus equals 1? That's our little shorthand. Yeah. We can't get, I know, as Icefire says, is there count plus plus? That was just what I was about to say. You know, if we're coming from JavaScript, we might want to do that, but we can't. So we have to settle for the slightly less cool option of this, but it's okay. We'll live. Thank you, Math. Yeah. That's sad. I know. All right, let's save it. We'll run it again. Okay, what's our file name? It's that. Actually, again, I'm just going to leave this blank. I don't need to type it. All right, so 27. I think we're cooking, chat. I think we're good. And remember, I did try this one earlier, but I didn't submit it. So I don't know if this is right, but it seems right. We'll see. Oh, that's all messed up now. What are you doing? Okay. Let's see. Okay, my screen is kind of janky now. All right. So, length, short, open, split. Words, okay. Print. All right, let's try that. We might need to put an additional check in there. We'll see. But we'll see if this is close enough. Yay, we got it, chat. Go us. But yeah, the other check we could have done is instead of saying if length of words is greater than 0, we could have also said, if words exists, right? We could just say if words, if it's not an empty array, right? Or if length words is equal to 2 to make sure that we had both index 0 and index 1 there. So length words is greater than or equal to 2, I should say, not equal to 2, but greater than or equal to 2. Yeah. Hey there, welcome to the stream. Thank you so much for the follow. Good to have you here. Server Horror says short circuit. Do we know error handling already? So I know short circuit from JavaScript, which is kind of what I was referring to. Yeah, I do believe this course touches on short circuiting though, in the lesson where it talks about like or and. But when I thought of it, the reason I used the JavaScript syntax is because I was thinking about short circuiting in JavaScript. But I believe we have already covered it in like lesson 2 of this course. Yeah, like a ternary statement. Yep. Okay, good job, chat. We got through the exercises. Wow, we covered a lot today, right? That was nuts. We do have a quiz, but the quiz is going to take place at the start of the next stream because, and I'm doing that on purpose. We could plow through it today, no problem, but that's not the best way to learn stuff. The best way to learn stuff is to practice it after you learn it and then revisit it. And we talked about some gnarly stuff this time around. We talked about some theory. We talked about some abstract concepts. We talked about references to objects and values and how they're different. And you learned like 10 vocabulary words. And so we are going to let those kind of sit in your brain. And then we're going to take a quiz on it next time. And we're going to see what fell out. We're going to work on it together. We're going to do the quiz together next time. and we are going to test ourselves to see how much we remember and how much is still confusing. And so that way we can, review anything that is not clear. Yeah, spaced repetition, exactly. Yeah, our review is going to be the quiz, Icefire. Our review is going to be the quiz, and we're going to talk through each question, and we're going to talk through, like we have been doing, we're going to talk through each of the answers and why they might be right, why they might be wrong, and I'm going to be doing the quiz with you. So it's not something that I'll have submitted beforehand or anything like that. We're going to go through it together. And we're going to talk about, agree on which answer is the best and why, like based on the concepts that we've learned. And if there's anything that we don't know, we're going to open it's an open book quiz. We're going to go back to the lesson and we're going to find it and we're going to figure out what the best answer is. Barbara Oakley fan club. Heck yeah. A hater. They say, when will be the next lesson? It will be, let's see, when is the date? I need to double check. Yes, so we will have a stream next weekend. And it will be next Sunday at 3 p.m. Eastern is when it starts. So we start at 3 p.m. Eastern and we go until we finish the lesson, really. So yeah, we're going to start with a review next week. So 3 p.m. Eastern is when that'll start. Then we'll go until we get through the next lesson. Keep in mind that American Thanksgiving, so our Thanksgiving holiday, is coming up 2 weeks from now. So just keep that in mind. I don't think I will probably have a stream that weekend because it's a holiday. But I will announce that. So once again, please follow me on Blue Sky. That's where I will be, announcing any changes to my schedule, stream updates, that type of thing. So please make sure you're following me on Blue Sky. So, you're aware of any changes. Do ! Blue Sky if you want my Blue Sky information, but you can really just search for Mayan Wolf on Blue Sky and I'll come up. So please follow me there. I do, also have a Twitter account, but I am really, really, really trying to transfer all my followers over to Blue Sky for reasons. So yeah, please follow me on Blue Sky. Yes, and you can also search for 100 devs and find other folks in 100 devs if that's what you're interested in. I have to try to build out my profile, and I'm trying to learn how to use Blue Sky and all the tags and stuff. So I'm working on it. We'll get there. But thank you to everybody who has already followed me there. I have several hundred followers already, which is nuts. It's going to take a while to build back up to like my 12,000 on Twitter, but hey, I'm in it to win it. I'm in it for the grind. So yeah, eventually my Twitter account will be deactivated, so you won't be able to follow me there anymore. Blue Sky will be the main source of truth for, stuff like this: stream schedules, stream topic, announcements, cancellations, any of that stuff. Go cold turkey, go hot dog. Percy says, "Are you using Python professionally?" Not at the moment. No, This is me learning Python. You are watching me learn Python right now. I have already applied it. I wrote a script that looks into the future and finds all the possible holidays for a project I'm doing at work, but it's not something that I currently use regularly because I didn't know it until a few weeks ago. So yes, you are watching me learn Python right now. We're going to get to some topics later on data engineering specifically. And that's what I'm really interested in, working with large scale data efficiently. And so once I've done that, then I expect to be able to use it professionally for my day job. Yeah. But yes, so check me out on Blue Sky. There you go. Guess that really doesn't give you anything, but it's just at mywolf.bskysocial.app. So if you put my name in the search bar, you'll find me. Yeah, Blue Sky is a really awesome environment for devs now. So that's what I've been discovering. I'm still getting used to the whole feeds thing. I'm not very good at that yet, but I'll get there. I learned how to use Twitter. So, oh, thank you for direct linking to my profile, Matthias. Yeah, that's helpful. Thank you. All right, now before we wrap up, somebody did have a question earlier, and I tabled that question because I really wanted to get through the exercises. But they asked, what does a SQL engineer do at a major university? And I'm be happy to answer that question before we wrap up today. Percy says, I was very reluctant to open Twitter until Leon convinced me. Now I have to close it. Yeah, this is all very recent. This mass exodus to Blue Sky. So it's up to you what you do, right? It's up to you. I would suggest opening a Blue Sky profile. Just because the dev community is really blooming on Blue Sky and you might be able to connect with more people there. Well, Matthias says even Leon is there on Blue Sky. Yeah, only because I convinced him to do it. I don't think he's posting anything yet anyway. Because I think I'm following him in there. I was like, Leon, open a Blue Sky. This was like months ago. He'll get there though. He'll move over. Yeah. Exactly. As Strain said, playing the game probably means having an account on each, at least for now. But you do what works best for you, right? You should, do what works best for you. And also, just FYI, I have asked Leon, I can't do this directly, but I've asked Leon to please edit the 100 Dev sign up so that people no longer have to follow my Twitter as part of the sign up. I want to change it to my Blue Sky account instead. So I've asked him to change it. I don't know when he'll do that, when he has time. I'm hoping he will do the same with his account as well. Okay, anyway, what does a he did something. Oh good. Okay, he's getting there. He's getting there. What does a senior SQL dev at a major university do? Yeah. And you might say, why does a university need SQL developers? What? I'll ask you, chat. Why do you think a university needs SQL developers? Yeah, that's really the answer. Strain said so much data. Exactly. Yeah. Hey, we all can prosper. Welcome to the stream. They say unis have huge data needs for a lot of things. Exactly. So think about this. Think about how many students attend a university. All of those students have academic schedules. They have grade histories. They have quizzes. They have tests. They submit those tests electronically. The professors are all doing research. We have to keep track of how much research they're doing and when. Every single student and professor and staff member has to eat, right? Do they have a meal plan? How big is that meal plan? Where do they live? Do they live in a dorm? Do they live in an apartment? What's their email address? Where do we send their grades? Have they gotten a transcript? Are they graduating? When are they graduating? How many graduation events are we having a year? Who's coming? Are they bringing a guest to the graduation event? When did they get their diploma? Did they go to high school? Did they go to college? Have they been to another college? When did they come to this college? All of those things, and this is just a tiny fraction, all of those things generate data, right? Those are all insights that you need in order to run a university. And the only reason I was able to rattle off those data points so quickly is those are things I work with all the time. And those are just some of the things that I work with all the time. We keep data on every student who's ever been to the university since like 1970, how, where they came from, where they are, what's their contact information, because you never know when you're going to need that. And, what class did they take? When did they graduate? All those things. And that's all just the student stuff. That's not even getting deep into the research part. Professors are doing research. We have a bunch of different research arms. We have lab animals. All that has to be tracked. We have every single door swipe. You have to swipe in and out of buildings, right? We have to keep track of all that. We need to know who clocked in where. We need to keep track of, employee timesheets, job applications, where people are and when and why. Are they approved to be there? The data points are almost endless, and all of that has to be collected and curated. We have to make it so it's accessible to people, right? And that's my job. So my job is to be part of a team. My job is to be part of a team that maintains that centralized data storage at the university. So I don't do the analytics directly. But what I do is I make sure that data is accessible and usable by the people that do the analytics. Yeah. So, and it's important distinction. I'm not a DBA. So DBAs are the ones that handle the security, they handle the access, they handle the actual like hardware that the data is stored on. They're, managing the all the meta stuff around the databases. I'm just making sure that the data looks the way that our customers want it to be. And that's a common distinction that people don't quite understand, the difference between a DBA and like a database engineer. So a DBA is a database administrator. They're the ones, I mean, our DBAs are the ones that could, cut off my access. They're the ones that control my access to the data and everybody else's access to the data. And the threading and how the data is processed and that type of thing. I'm controlling the content. Yeah, exactly. Yeah. So a database analyst also is not a DBA. Yeah. So DBA is database administrator. Ziso says, so you're saying a lot of stuff computer science students get an opportunity to try themselves, to find backdoors and test you. Again, yeah, I'm not really, I'm not in charge of any of the access. I don't know any of that stuff. But I'm more in charge of content. So a customer comes to us and says, hey, I want to see, I want to be able to quickly analyze every student's graduation ever, whether they brought any guests and like what graduation ceremonies they're associated with. So maybe they got their bachelor's and their master's and their doctorate, and each time they brought one parent, but they didn't, maybe they couldn't attend their master's graduation, right? A customer wants to know that. And so we have to pull that data together out of a bunch of different systems and make it and turn it into something that they can analyze. We don't care what they're going to do with it. We don't make any of the insights, but we frame the data in such a way that they can make those insights, that they can do that analysis that they want to do. Buit says, so you're the one we go to for better grades. No, I'm afraid not. Nope, can't do that. We actually have a lot of our data, pretty heavily locked down, and it's depending on what type of data it is. I can curate it, but I can't edit it, which is good, right? I don't want the ability to change that stuff. A lot of our data is fed from source systems, and we just join the data together and maybe transform it a little, right? We might change the formats. We might create new fields that are calculated based on the base fields. But a lot of it comes from source systems that we don't directly control. And so we have to control for things like user error, right? Emojis, garbage in, and we have to make that look less like garbage. That's a lot of what I do, honestly. Data cleaning. Strain says, if you ever need a copy of your transcripts, Mindwolf or their equivalent had to set up pulling that data. I needed a copy 20 years after graduation and still got it in under an hour. Yeah, that's because of things like data warehouses that track every student that graduated ever. And so what probably happened was, someone like me set up the underlying data, and then there's a front-end reporting tool, something like Tableau maybe, or there's a lot of different ways. Power BI, Tableau, Cognos, those are all user-facing reporting tools. So somebody didn't have to write any code to pull your transcript strain. They were able to access a reporting system that essentially was a GUI on top of a database. So a database engineer set up the database, and then an analyst was able to use a GUI to access that data in a friendly way without having to write any code. And then they were able to pull your transcript. So they were able to then probably just enter some data in a search box and do a query, a GUI-based query against the existing data tables and pull back your transcript. Yeah, and even so not every dev job at a university is going to be a back-end job either. Universities, all universities have websites, and they have both external facing and internal facing websites as well. So, you'll have stuff that's available to the public. So when you Google that university's name, you're going to have websites that anybody can access. But then you're also going to have a huge internal web infrastructure. So web apps to do things like enter time off, or look up the HR manual, or, get IT support, right? That's all going to be web-based. And so somebody has to write that as well. So not every university dev is going to be a back-end dev like I am. Some of them are going to be, front-end devs, designers, user experience specialists. All those are needed as well. Ziso says, I understand you're not the one who's responsible for data security, but hearing what type of data gets collected worries me each time. Security is often really weak. Yeah, so, we go through pretty rigorous audits in terms of security. We just went through an audit, actually. I don't know the details of it. Again, I'm not in on that. Yeah, we go through security audits. We have to meet the standards, national security standards or whatever for data protection. So yeah, we do adhere to all of those. I can't speak to the quality of security, but we do go do regular audits, and we have varying levels of data security on our data structures. Matthias says, so you're providing infrastructure for CS students without having studied this. Did you ever think about this? Yeah, I love it. It's great. I don't have a CS degree, but I'm able to support students who are getting their CS degrees, which I think is awesome. And I think it also illustrates, how you can kind of, with coding, you can kind of choose your own adventure, right? Some people are going to go the CS degree route, and that's great. Some people like me are not going to go the CS degree route, but we could both end up at the same place. I have a coworker right now who did get a CS degree. He and I are at the same level. He went the traditional route. I went the data analytics route and ended up here. And we both, we both bring a different perspective to our roles, which is great because we can contribute different things. I think that's awesome. That's one of my favorite things. I've said it before, but one of my favorite things about working in this industry is the different backgrounds of people, right? So you're going to bring people with different perspectives, and that brings such a diversity of opinion and diversity of knowledge that can really lead to some cool stuff. Yeah. Yeah. Ziso says internet versus intranet. Yeah. So we have, the outward facing internet sites and apps and that kind of thing. And then we have a whole intranet, which is only accessible. We have a bunch of stuff that's only accessible on our VPN tunnel. So you have to be, two-factor authenticated to access the intranet, which is internal to staff members and that kind of thing. Yeah. Pace says, do you know where the uni's data center is? No idea. I mean, I know we have physical servers somewhere because there was one time when we kept getting like dropped packets and stuff. We kept getting essentially data loss, which is really bad. We were literally losing data. Data was coming in from outside systems. And when it got written to our database, we would literally have like missing records and corrupted data and failures. And it was awful. And, we were getting calls, like emergency calls every night as things were failing. And it was like the worst week of my career, I think, because I was on call. So I was getting called every night and getting zero sleep. But anyway, we finally got the right people in the room, and they physically went to a server room somewhere, and they found out the whole cause of all this nonsense was a cable that was a little bit too tight. So a physical cable between like two server racks somewhere that was a little bit too tight. And that was causing like our entire team of like 8 people just utter misery for like a week and a half. Yeah, it was wild. And we were like when we finally like heard the root cause, and they fixed it, like all we could do was laugh because we were just like, this is insane. Cable loosening so hot right now. Yeah, I choose to imagine that, in this data center somewhere, there's all these big server racks and there's cables everywhere, and somebody just rolled their office chair like over a cable, and it just kind of snagged, and they rolled a little bit farther away, and it just like stretched the cable a little bit. I'm just like, well, Jerry rolled his office chair over the cable, and it got a little tangled. Probably micro USB. As Ziso says, I believe most universities have their own data center. Yeah, we do, definitely. We have a lot of on-prem stuff, on-premises applications and data storage. Right now, our data warehouse is on-prem. We haven't done the cloud thing. We have some stuff in the cloud, but most of it's on-prem. So yeah, there's a data center somewhere. I have no idea where it is. Jerry went on PTO after that. Freud's Coke. Oh, that's great. Good to have you here. Thank you for the follow, by the way. And thank you for the follow, Besadek and Pace Dodo. Thank you so much for being here. Oh, that's awesome. You still working in data centers, so that's so cool. Yeah, I've been inside a few data centers, not the one that, we actually use, but they're always so neat. I like it. I've never really had an interest in the hardware side of things, but I think it's awesome how, you folks maintain those interconnected systems and hardware and stuff. I hope Jerry doesn't know where it is. Yeah, that's not a real name, by the way. I'm not slagging anybody real. Yep. Percy says there's a hackerspace in my city and they just made a server room. It's a broom closet. Hey, everybody's got to start somewhere, right? Hey, at least they aren't putting their server rack like, on a desk. I've heard some horror stories of, servers being run on like just a random machine that just has a sticky note on it that says never, do not power off. At least it's in a closet. That's all I can say. Yeah. But anyway, that was my very long answer to what does a SQL developer do at a university? And the answer is there's a lot to do. We have a team of I think we're up to 8 people now, and we still have more work than we have time for. We still always have to prioritize our work and organize it into sprints because there's always so much to do. Double check the physical connections, yeah. But yeah, so and that's kind of what yeah, exactly, more devs, more scope creep. Yeah, the more devs you add, the more work there is. But and I think that's the important thing to remember, right? Is people are always saying, oh, there's going to be no jobs for devs anymore. AI is going to take over everything. The thing is, companies are only getting more like technology heavy. They aren't going the other direction. Every company is a tech company. Every entity is a tech company. Even non-public entities like universities, right? Even stuff, governments, everything, even stuff that's not on the stock exchange or not an actual like for-profit company. They are tech companies. Nobody's going the other direction. Your local hair salon needs a website, or they need a database to track customers, right? We have somebody in 100 Devs who got their start as a freelance web developer, literally building websites for the Amish. And if you know what the Amish are, they're literally people who, for religious reasons, do not use modern technology. She got her start. Her niche was building websites for the Amish to advertise their businesses. And I'm not joking. So even the Amish are tech companies now. And so, that's why, like, I always say that I'm not worried about AI replacing us, because there's the only direction we can go in is more tech jobs, more tech roles, more need for more technology and more data. It's never going to end. And you need people to fill those roles. Yeah. So that's my impression of it. Freud's Coke, thank you for the follow. Hregoroni, thank you for the follow as well. Alrighty, folks. Any last questions before we wrap up? Great job today, folks. By the way, we covered some gnarly topics today. Some truly difficult, hard to understand stuff. Like I said, lots of theory, lots of more abstract concepts, lots of vocabulary words, and y'all did really well. So great job, folks. I honestly thought, like, and also props, like, I honestly thought this is we're on part 6 of this series. I was like, is anybody gonna be watching by like part 6? And yeah, y'all turned up. So thank you for that. I was like, I'm gonna be, talking to 5 people by the end of this. But you turned up, you handled the difficult stuff really well. We did the exercises. We did it. We got them all in the first try. Good job. And yeah, I think we're well prepared for double checking our knowledge next week. Alien Pair, thank you so much for the follow. Good to have you here. All right, folks. Feel free to ask any last questions. Otherwise, I'm going to find somebody to raid. And then I'm going to sign off and have dinner. 69 people, it's a sign. Nice. Yeah, honestly, I mean, the drop-off wasn't crazy. I thought by the time we got to the part about objects and values and references, people are going to be like, nah, screw this. But y'all hung around, so props to you. All right. Matisse Tech, okay. Yeah, and if you have any suggestions on who to raid, yeah, and if you have any, oops, sorry for the echo there. If you have any suggestions on who to raid, please let me know. Okay. Preferably somebody. Hey, Colkies, welcome. Good to have you here. Oh, thank you, Buit. Glad it's working for you. All right, let me get to. Kolki says, did I just find some educational content? Heck, yes, you did. Unfortunately, we just finished doing all the content. We are wrapping up for the day, but you're welcome to tune in next time, or you can watch the recording, which is available now on my channel. Yeah, I am a 100% educational streamer, Kolkies. Right now, we're covering Python. We're doing Python from start to finish. But normally I tend to stream like full stack web development. So again, educational content. It's all, meant to be learning exercises. We do projects, we cover concepts, we've done React. On a variety of topics. So if you're interested to see the types of things I tend to talk about, you can head over to my YouTube channel where I have my archive. So you can do !YouTube in chat to see my archive. But other than that, I mean, yeah, feel free to check out the videos tab on my channel. You'll see some of the more recent stuff I've done on Python. Yeah. But yeah, hope to see you at the next one. Thank you for the follow, by the way. I love it when people are excited to find educational content. That's rad. All right, I'm getting there. I'm getting to the raid. But yeah, Kolkies, I generally stream on Sundays at 3 p.m. Eastern. So whatever time that is in your time zone. Sorry. Check me out at 3 p.m. Eastern on Sundays. Also follow me on Blue Sky. That's where I announce like my stream topics and any cancellations or changes. You can check me out on Blue Sky. Just search for Mayan Wolf. I'm the same name there. I'm the same name everywhere, pretty much. If you search up Mayan Wolf, you'll find me. All right, getting the raid going. Raidy raid. Okay. Here we go. Oh, got another Pezliz. Bay says there's too many frameworks in JS. There are a lot of frameworks, yeah. Hey, thank you, Percy. Absolutely. Good to have you here. Of course, Machine. You've been learning Python and English at the same time. That's awesome. Good job multitasking. Way to go. Yeah, it's hard enough learning a programming language when you also have to learn a spoken language as well. Of course, Mattel, thank you for being here. Let's see. Let's check out whoever suggests Matisse Tech. Yeah, Matisse Tech. Let's see what they're up to. Okay, let's see. They're working on something. Oh, chat plays OBS. Oh, they're doing an interactive thing. That'll be fun. Yeah. Looks like they're doing something interactive that maybe chat can help out with. So why don't we go ahead and pop you guys over to them? Yeah, absolutely, Celeste. We've had some real bangers recently of people building cool like Twitch interfaces that like interact with chat, which I think is really neat. Yeah, hopefully it's fun. Yeah, we had that Minecraft one. We've had so many good ones. Like people who we've rated, who have had some really cool stuff going on. So yeah, we're gonna raid them. As always, please show them the same respect and follow the same rules that you would follow in my chat. Show them how awesome of a community we are, and show them some love as well. Interact with them, and yeah, spread some positivity and love, and maybe they'll raid us back someday when they're a big time streamer as well. All right, yeah, go ahead and raid them. Raid is starting now. Of course, Matthias, good to see you. And we're going to raid in about 10 seconds. I'm going to have to jump off. I'm really hungry. It is well past dinner time for me. So I'm going to have to jump off, but say hi to them for me. And yeah, spread some love. All right, rating now. See y'all next weekend.